Welcome back, everyone. We are here for day 7 of the completely free Go Cloud Careers AWS Solutions Architect Associate 2024 Bootcamp to help you prepare for that AWS Solutions Architect Associate certification and that SAA-C03 exam. And this is an AWS full course tutorial, and it is completely a free AWS course, and we are happy to be with you. So before we begin, tell me where you're from. I am in South Florida today. Today's probably the first non-hot day we've had. It's only about 90 degrees Fahrenheit. So not too bad for what we get here in the summertime. Little cool breeze. So for me, I'm having a great time. Where are you all at? What is the weather like today? Let us know. Love having you all here. So today was going to be day 7 of this program. Yesterday we covered a lot. And today we're going to begin with some of the AWS artificial intelligence machine learning services that are here. So welcome. And we'll get back to the fun in a few minutes. The format is we'll go typically 20 to 30 minutes or so, and then we'll ask some questions or answer some questions related to the content we're covering. And then we'll go back and forth for about 20 more minutes of content. And we're there. So I'm looking at this. I see people in Virginia and Ghana and South Africa and Cameroon and Argentina, all over the United States, which is good to see. I see Nigeria is here as well, which I absolutely love. I see some people in Georgia. We see some people in Sacramento, and lots of people in Florida, which is really great. So we're here. Richland, Washington. Haven't been out there in a little while. Kenya, I absolutely love this. So it's really great. So everyone is from all over the world, even Nairobi. I love that. So good to have people at Toronto. This is fun. Maryland. So love this together, and we're all here together to help you guys start off your AWS journey with this free AWS Solutions Architect Associate training. So I want to know you're here. I want to know you're awake. So please give me a hashtag AWSSAA to let me know that you are here for the AWS Solutions Architect Associate training. Please let me know that in the chat box, and then we'll begin. Also want to let you know that if you've just joined us for the first time, we have about 40 some labs for you to actually do on your own time. It's going to take us basically 3 hours a day, every day for the better part of 2 weeks to really cover the technology. What is that technology? How does that technology work? The use cases and business cases for using these types of technologies. And that's what we're focused on today. And I did this because when I interview people, I always ask them about the technology. What is it, how it works, and why do organizations use it? And 99% of the people can't answer that. And sadly, we just can't hire them. So I want to make sure you get some understanding of how it works, but I still want you to get hands-on. So go do that at your own time with those free labs. So go download them. I also wanted to let you know that Thursday morning, we're going to have our completely free How to Become a Cloud Architect, and go out there and get your first cloud architect job webinar. And what we'll do on this is we will talk about what is the role, what do we actually do as cloud architects versus what people think we do as cloud architects, what are those skills you need? And I'm going to tell you right now, at least 50 to 60% of those skills are business skills. And we'll also talk about those technical skills as well. We'll talk about how to bypass HR when it's your first time, and to go and directly be seen by the hiring manager. And it's all going to be free. So come join us. It's completely free. And it's on Thursday. It'll be at 11 a.m. Eastern. And you can figure that out where the time zone is in your local time zone with a simple time zone calculator. If you're like me and you just know where all the time zones are because you've traveled too much, you just do the math in your head. So all completely free on Thursday. So now that we've discussed these, let's get into the content. So yesterday, we left off with wavelength. Today, we're going to get into Amazon Kendra. And Amazon Kendra is a search service that's powered by machine learning. So think artificial intelligence. It's going to help organizations build accurate and powerful search capabilities into their applications. And it's going to help users find the information they need quickly and efficiently. And when you start thinking about how do these systems work, in most cases, we want to be able to ask a relatively reasonable question. Go find Cindy the cat photos. So somehow along the line, the AI needs to take what we asked it understand it and the context of what it is and turn that into a user query. And realistically speaking, and also be able to read the content and understand that. So that's typically where we're talking about natural language processing. And Amazon Kendra uses natural language processing. So you can ask a normal question. And that's something we're going to see more and more of. I mean, this is not new, Kendra, and natural language processing is not new either. But you'll see that over time, much more of these AI systems get much more responsive to natural language. So where we might need prompt engineering now, 2-3 years from now, you probably better ask AI the exact question you actually want, and it'll come out because it'll understand you. But that's just more information in this type of world. So whenever you're dealing with any kind of machine learning environment, you're going to have to tune it. It's not just going to come out of the box and great. So Amazon Kendra gives you some tools to provide some relevance tuning, and you'll be able to customize the search relevance based upon the organization's need. And you'll be able to adjust that relevance by tuning it to user feedback or user behavior. So you might start it, and it may give you some stuff that's not really relevant to you or appropriate, but you can tune it and make it what you need it to be. And that's what we're talking about here. Of course, this goes through with any AI system. Amazon Kendra can kind of connect to many data sources that you think out there. You instantly think of things like S3 or an Amazon Relational Database Service, but there's other stuff out there. There's SharePoint, there's Salesforce, ServiceNow, and Amazon Kendra will integrate with those as well. And it'll integrate into your cloud data sources as well as your data center data sources. So it's going to be a customizable search experience when you use Amazon Kendra. And obviously there's other alternatives as well, but this is a cloud native version. So you might be able to define your document attributes. You may want to add metadata to your results. And it's going to give you the ability to customize the user interface and the search experience so that it works for the organization's needs. It has the ability to provide, say, an FAQ and answer session. So you may find that you've got a lot of questions that typically get asked in a corporate environment. And sometimes having an FAQ page will make it easier. Usually people don't read the FAQ page and still ask the questions, but some people want to just do a search and find it, and Amazon Kendra will help you here. It will extract raw information from documents, FAQs, manuals, and it'll add that to the search. So it can make it easier for people to find what they need. So they don't just say, okay, you've got a FAQ page, but I don't know. Let's call the 1-800 tech support number. Now, whenever you're looking at something, you might be searching for something. You may get 1,000 results. Now, some results are more relevant to what you're looking for than other stuff. And Kendra has the ability to perform ranking of your documents and look at the relevance of each based upon machine learning. So you can use this because it's a machine learning service to provide some analytics and insights. It'll give you detailed analytics into your search performance, the way your users behave, and that's going to give you good information on how others interact with you. And that way you know how you can interact with them better, what kind of improvements you make, if you will. So let's talk about where you might use this. So enterprise-wide search. Employees are looking to constantly find information. And if you can cut the time down that it takes for an internal employee to find something like an internal document or report or other resource, that means enhanced productivity. If the employees do more and they're more productive, the organization has the ability to pay their employees more. If people don't do more work than before, the company can't make more money with the people that it has, and it will need to hire more people to get the same thing done, and that will lower the pay that people get. So anytime you can enhance productivity, it improves profitability and employee earnings, typically speaking. So where else could you use Kendra? Customer support. So lots of times people just call support because they can't find anything. They don't know the answer they need. Now, if Kendra can help people find what they need when they need it, customer support cases can go down. And the person doesn't have to wait on hold to find somebody a half an hour, which gets them frustrated because they were able to find it themselves. So lower cost because you don't need as many customer support people. And the customers have their systems working when they need it. So again, they're going to be happier as well. Knowledge management systems. Here's another use case you may see something like this. So lots of organizations have their own knowledge management systems, but at some point they can get so big that it's actually hard to find what you need. So this can help an organization. Just think of it. If you can find what you need and get access to good information that's relevant to you, it cuts down your search time. It cuts down your research time so people can do more. Again, enhancing productivity. How about e-commerce search? Another use case for something like this. Because what if you wanted to put a product search capabilities into a website and provide relevant information? For example, my cat Cindy loves these things called Bonkers Purr Pops. And no, I'm not paid by them. I bought 50 packs the other day because she loves them. They're these little tuna lollipops. I bribe her to come over with me, sit on my lap, and eat the lollipops. They're great. But I can tell you, I went to search the stores that had these lollipops, and I got basically every other unrelated product that I was looking for. And I was thinking there's got to be an easier way. So I went to the pet store with my wife until I could find them. Now, if you can get a good e-commerce search and you can look for things and you get all these relevant responses, people are more likely to buy more. Again, enhancing an organization's profitability, which puts it back to the same situation of higher profitability, better returns for the shareholders, better take care of the employees. I can personally tell you that Amazon Kendra, a good use case could be healthcare and life sciences. I can tell you from my old days practicing internal medicine when I was a nurse practitioner, trying to find stuff. You either used one of the books that you carried with you that was reliable information, or you bought these applications that were giving you good sources of information versus whatever the fluff is that you might find on a Google search. These were accurate, well-researched information. So if you can research, 50 medical journals or 500 medical journals and a library of hundreds of good and legitimate medical books, when you're trying to care for your patients, this kind of thing can help you find what you want much faster. So improved clinical decision-making could result in less medical errors and lower costs because there's less research. So how do you basically set this up? So how would you use it? So for one thing, you go to the management console and you navigate to Amazon Kendra. You basically create an index and configure the basic settings. Now, it's machine learning, so it needs data. So you connect your data sources, either with the built-in connectors or some custom data connectors that you could create. And once your data is connected, you define what the search experience is going to be like. You define maybe custom attributes or metadata or how you would tune it for relevance. You set up your frequently asked questions and document ranking to make sure you enhance the search results. You deploy it. And you integrate Kendra with any APIs you may have in your applications. You deploy any search interface that you want your users to start using, and you start using it. Of course, you're going to collect feedback. Now, with anything else, we're up, we're running, we're going to monitor it. See what's working. What's working well, do more of it. What's not working well, we do less of it, and we optimize. Let's think about some best practices, because remember, it is machine learning. So if you give it garbage information, you're going to get garbage results. So you want to make sure anytime you're using any type of AI system that you optimize your data quality and you perform good data hygiene and you feed it good data. And as the organization has new data sources, feed that into it because you got to optimize your data quality. Now, anytime you create anything, you're going to need to tune it along the way. So look for user feedback. Deploy it, collect user feedback, analyze the feedback, and look for areas of improvement. Typically, that's where the relevance tuning is going to come place, and you're going to have to adjust the search results based upon the feedback of the users, and then you'll tune it. Now, here's something to think about. AI needs data, right? And AI can do scary things with data if it's not designed properly. You could optimize your data and by, for example, removing personally identifiable information. And AI can add the personally identifiable information backed off on other attributes if you don't set up your models and tune your models. So, when we think AI architecture, there's a lot of things to do. But Kendra, like any other service, we've got to secure our sensitive data. Because now you're providing search to something, so we don't want the wrong people getting access to the wrong stuff. So make sure the search is going to comply with the organization's security policies. And really think about how do we make it better? How do we make it better? Look at your search analytics. Look at what's working and which areas need to be optimized. Update custom attributes and metadata to reflect changes in the organization's information landscape. Because It's all about information, good information. This is just going to analyze information. If you trained a doctor and you didn't send, and you gave them wrong information the whole time during the training, they're going to be a bad doctor. If you trained an airplane pilot and you gave them bad information, the plane's going to crash. With AI, and as we talk about more and more AI services, which we're going to, the quality of the information is going to be everything that you give it. Okay, so now let's talk about another artificial intelligence service on AWS, Amazon Comprehend. Now that is going to another natural language processing service, but this one is going to use machine learning to uncover insights and relationships in text. So I want you to think about it. It's going to be able to read the text. It's going to analyze the text and look at things like various linguistic and semantic features. And it's going to be able to read the text and understand it. So think about where a company might use this. Customers may leave a lot of information. This will give you a chance to analyze what the customer information is. For example, that's something that's pretty great. You can get customer sentiment with this. You could do a focus group and analyze the information. So typically speaking, this is where something like this kind of tool would be great. So it's going to recognize people. So it'll identify categories in text, people, places, dates, quantities, that kind of thing. It can recognize any kind of custom entity that's specific to your business that you need to tell it. It can do sentiment analysis. So when you give the speech, you want to read the audience, right? Can't do that on YouTube, but you do when you give a speech or a presentation to a big audience. And in today's world, there's AI that analyzes the audience sentiment too. The AI will analyze the audience sentiment, and somebody will have a little mini speaker in their ear, the speaker, and they can say, not work, and talk or pivot about this to something else. And if you see big, high-profile speeches, you may see something like that. So here it's going to analyze the text for sentiment analysis. So, for example, if a company is, lots of people are saying bad things about a company's product, it gives the company a chance to go fix it and find out what it is. So, analyze feedback, analyze people's social media posts, analyze product reviews. It's going to be able to analyze the syntax and the structure of the text, and it can identify parts of speech and relationships between words. Which, again, a word by itself may be nothing. Taken out of context, it could mean something, but in context, it could mean something else. So, it's going to help with that. It's going to determine the optimal language too. And that's going to be something you need to be able to think about is, what language is it actually coming in? And you may have to analyze multiple languages at the same time. There's lots of countries that have two languages. Cameroon has English and French, right? Canada has English and French. Greece has Greece and English for the most part. You could be on Cyprus and you've got Turkish, you've got Greek, and you've got kind of that Cypriot language, which is, even if it's Greek, is a little different than Greek. It's because it's a dialect, and that's okay too, but it really doesn't matter. So lots of times you're in a business that you have to analyze multiple languages, and this can do that, like many other great tools. Let's talk about key phrase extraction. So it can look for key phrases in a text. Another thing you could do with something like Amazon Comprehend is summarizing documents and extract some important information. So there's lots of tools to do these, but these are some of the Amazon branded tools. Well, something it can also do is something called topic modeling. And it can analyze a large collection of documents to identify the main topics that are covered. And this is some place where you can group documents by topic and get insights and themes. So, in science, you may be doing, like, say, a meta-analysis where you're going to analyze tens of thousands of documents and other studies by something that can go through and kind of give you an initial summary that's a little better than the abstracts that are on these documents. It can really help with some things in scientific research, those types of things. And another thing that it can do is to personally identify data information. So there are times where organizations accidentally populate personally identifiable information and make it public. Now that can be a mess of fun. Now, lots of machine learning services can analyze the data and tell you you've got personally identifiable information. Sometimes they're right. Sometimes they see things that is not personally identifiable information. And but at least you know to look there. So any of these tools are going to have false positives and negatives. Just keep that in mind. So where would you use this? And as I went through the features, I kind of talked about it, but let's go through these use cases again. Customer sentiment analysis. Analyze customer reviews or surveys or support tickets and understand the real issues. Identify trends and common issues so you can make your customers more satisfied. Personalize content to the users by giving them content that's relevant to them. For example, I'm constantly buying stuff for my cat because I love Cindy, the cat. Sending me stuff for dogs is irrelevant to me because I don't have a dog. Not that I don't love dogs. I love all animals, furry and feathery. But the thing is, I don't have a dog. So if I'm online at some online pet store, send me more cat stuff versus dog stuff. I'd be more likely to buy it. Social media monitoring. Now, this is pretty important. Monitoring social media channels to be able to gauge public sentiment and identify trending topics. Organizations really need to monitor social media and figure out what people are saying about them. Now, that can get pretty costly, but they need to know what people see as their brand. Because, they may think they know their brand, but the brand is what people say about you or your company when you're not there. So they can do lots of social media monitoring. Fraud. Here's another good use case for it. Look for fraudulent signs of fraudulent activity. You can, if you're going to be able to mine through multiple documents or hundreds of documents or thousands of documents, and you know what patterns of fraud look like in financial documents, you can search for that to try to catch these things. So lots of good things you can do here. I talked about healthcare and life sciences. I talked about some other environments as well. How do you set it up? Pretty easy, like anything else. When you know what you want to do, setting it up is kind of nothing. You go to the management console or the CLI and you click Amazon Comprehend. You choose whatever text analysis features you need, and then you configure them. Then you upload your data because you got to train it, right? So you upload your documents into it and use the API to integrate any kind of text analysis in your applications. Next thing you do is you look at the results. You review the results and you analyze them and use these insights to drive any kind of decisions you need in your actions and the way you would set up your applications. Obviously, you're going to need to customize your models. You may have to train custom models, whether it's related to entity recognition or text classification, should it need be. And you can provide your domain-specific data to prove the accuracy and relevance of the analysis. You integrate it and you deploy it, and you see what works. You look at the test analysis to automate and scale your text processing, and you see how is it working. So those are there. So we'll discuss Amazon Polly, and then we'll take 10 minutes to see if there's questions. So Amazon Polly is a text-to-speech service that converts written text into speech. You see this stuff all the time. You got a ChatGPT, and it reads to you, for example. There's lots of these that are there. And Amazon Polly uses deep learning technology, again, AI, to synthesize speech to make it sound like a human voice. So there are organizations that will create applications that talk based upon the words that are on the page. We're getting to a point now that there's lots of lifelike voices with AI. And they typically call it this, they would say that they would support standard and neural text-to-speech voices. But the point is, it's reading the data, it's being trained on more natural voice sounds, and that's going to give you a lifelike voice. Now, it's not just language. It should be in the language of the receiver's choice. And ideally, it's in the dialect of their choice. I mean, let's face it, there are multiple dialects that are out there. I lived in Philadelphia as a kid, and they drank soda. And I don't drink a lot of soda, but I was someplace else, and I ordered a soda, and they looked at me like, what do you mean? But they called it pop. So the point is you might even need multiple dialects in English multiple dialects in any other language. There's lots of them, and this can help out with that, especially to customize it to make it sound like your receiver's used to hearing. So you can do both real-time and batch processing with Amazon Polly. You can convert your text-to-speech in real time for like an interactive application. Maybe you've got a shy person and they want to type something in and have it talk to somebody else. Or you can do batch processing and go through a library of text and make it audio text for people to listen to in the future. One of the good things about Amazon Polly and applications that it gives you the ability to create a custom lexicon. So I might have a back patient who has pain shooting down their leg, and I may call it lumbar radiculopathy. But if we just ask AI to call it, it may not know to call it radiculopathy because it may not be trained on those words. So lots of times we need to create custom lexicons. Lexi comes from it means word in Greek. And, we have to increase the naturalness to get people to adopt these technologies. So we teach it how to pronounce certain words, and that's something else you can do with Polly. Now, you're going to have to determine, of course, Polly supports it either way. Do you store the voice into, say, S3 or object storage? Do you put it in your applications directly? And it can enable you to do either or, streaming audio, or just drop it off and dump it into object storage. So where might you use something like Amazon Polly? Well, you might use it to create a voice assistant. I have friends that have smart homes and they've got voice assistants and they want to talk to this thing and it works. Personally, I shut off anything that has that functionality. I don't want to give hackers an opportunity to get access to my systems, but that's just me. You might use Amazon Polly in an integrated voice response. So say you've got a customer service environment and you've got a customer, they're calling in to get tech support, and you may want to constantly update the menu of the tech support. If you're calling about the Windows and CrowdStrike outage today, please listen to the following message. Press 1. If you're calling regarding this, this, and this, please press 2. I meant the Microsoft and CloudStrike outage at the same time, the same day. So, those kinds of things. You might want to have that system that you call. It's called an IVR system or an integrated voice response system. You may want to tune that very quickly and on the fly. You may want to talk to someone and read some text to them. E-learning is another place. Now, quite frankly, when it comes to e-learning and any e-learning that I provide written content and video and spoken content, because you have to get both, and for a lot of different things. Some people like me prefer to read. Other people prefer to watch movies. So with Polly, you can kind of tune your learning environment. I can tell you when I did my MBA for this, I did 2 MBAs, but I know when I did my MBA, I was driving 4 hours a day back and forth to work and school. So I listened to an ebook every other day. And it would have been hard to be reading while driving. I wouldn't recommend that, and I don't recommend that, but I was able to listen to audiobooks. So if this could have just taken an audiobook that I had, maybe I bought an audiobook and it could just read it to me, that would be great. So not that we would do that with an audiobook, but we can take information and have it readable into audio format. Media and entertainment can literally create any kind of voiceovers for a person's podcast if they wanted to, or you've got a YouTuber that's streaming. I think they stream games, or maybe it's Twitch that they stream games on. I don't play games. My brother does. He loves them, but I don't. But there's constantly all this stuff going on in the background. That would be kind of cool. And potentially talking on the videos, he or she would type something in a chat box and that could talk on the video and make it sound lifelike. So all kinds of cool stuff. So how would you set this up? You go to the management console and click on, and you go to where you were at, and you go to Amazon Polly. But you could do it on the CLI or the APIs as well. You explore the available voices and language, and you choose the best fit. You take your text next, input it, and it gets converted into the speech and the voice and the language you choose it to. You integrate it with your applications, and then you stream your audio live or directly. You save it to, say, S3 or object storage for later use. You set up any kind of custom pronunciations of certain words, and you basically refine, and refine. And this is really that custom lexicon really makes the difference. For example, last night my wife and picked me up something called the Gyro, Gyro. It's a Greek thing. It's really great. But anyway, neither here nor there. We call it gyro because that's how they say it in Greece. Americans call it gyro. So if we were going to have this and we were going to take something in English and say share it with a Greek audience, we wouldn't want it to say gyro. We'd want it to say gyro. And it's the same word and the same spelling and a completely different pronunciation because it's a custom based upon the language. And that's where you would tune it either for a common lexicon or that's where you would tune it for a dialect, that sort of thing. You'll fine tune as necessary. You should be good to go. So, what are your best practices here? And I know I alluded to this the entire time. So, best practices are really get those lexicons right. And that's why I harped on it for so long. Anytime we use AI, we've got to get it to as close as lifelike as possible. When we had video conferencing, when we first started out there, the studies we showed that if the person was as big on the other side in video conferencing as they were in the real world, people were more likely to adopt video conferencing. And we were setting up these high definition video conferencing systems that were lifelike throughout the world. Now people have adopted to, being remote and using a computer screen, but they wouldn't adopt it unless it felt like being there, at least initially, because that was the culture. So we had to optimize everything. Same color backgrounds in the room, so it felt like people were in the same room. There was so much that went into it. When it comes to feeling real, it's got to be right. So optimize those common vocabularies, those pronunciations, etc., that you need to do. Constantly monitor these things and tune. Use natural voices. I mean, if you wanted to talk to people, it should feel like a real person. If you choose a robot voice, this is the trade-off here and there. I mean, nobody's going to want to listen to it. So the plan is to make it feel real. So try to go as natural as you can. AI will let you do anything you want, but you really want to make it work for the user. So that's for Amazon Poly. When we get back, we'll talk about Amazon Rekognition, another AI service, but let's see if anyone has any questions. Tyrone. Does an AWS architect, when building an architecture, also need to produce a pricing prediction, how much it will cost? So, Maury, a cloud architect or an AWS architect or an Azure architect won't be building anything. I encourage you to come tomorrow to the completely free, on Thursday to the completely free webinar on how to become a cloud architect. But I'm going to make it very clear that's not something that we do or do at all. Here's what we do for real. We meet with the client and ask them about the goals of their business. Where do they see their business now, 6 months from now, 12 months from now, 5 years from now, and 10 years from now? Then we go and evaluate, how does that business operate? What are the key business processes? How is a product made? What's the supply chain look like? How is customer service delivered? How is customer support delivered? How is any? So we have to figure out how the business works. The thing we do after that is work with that business to design the way they want that business architecture or those new business processes, because those business processes will affect their technology selection. The next thing we do, Maury, is we go in there and we baseline their systems. So we go in there, we bring in a team of engineers. Those engineers will go and monitor those systems. They will look at the performance of those systems, things like network utilization, CPU utilization, DRAM utilization. They'll search through everything to figure out what's working and how the technology is working. We will then go, now that we know the ideal business processes and we understand their current technology, go and build a team of 15 to 50 people for the next 6 to 12 months. And when we build that team is going to go out there and we're going to create the architectural strategy. So if I'm the cloud architect, for example, what we're all going to be doing is I'm going to be coordinating a team. I'm going to have a couple of of network architects. I'm going to have some security architects. I'm going to have some AI architects. I'm going to have some DevOps engineers. I'm going to have some cloud engineers. I'm going to have some software developers. I'm going to have some security architects. I'm going to have some IAM architects. I'm going to have a big team of people. And together we're going to say, what are the technology tools and trends that we have to be able to go solve those business problems and goals the customer told us about? After that, the customer will typically, issue like an RFI, RFP, or RFQ. We will lead the team that will respond to that RFQ. The team together will design that architecture, and we will document that architecture. Various teams will draw the pictures for the respective reasons. We will then document it, and if it's a big deal, we will take our document and responses, and we will send that response, our architecture documents, to the graphics team and another team of people that are professional editors. They will take the graphics we give them, they will turn them into something beautiful, and say Adobe InDesign. They will create all kinds of beautiful documentation. Our documentation will clean it up, and then we'll deliver it to the customer. The next thing we will do is with that customer, we'll help the sales rep sell it, and we'll help them negotiate the deal. And as soon as that process is done, we will go off to our new client. So we don't build anything. We don't touch the technology as architects. And that's why when I've got cloud engineers with 10 years experience, they take the same amount of training as a nurse. So it's a different job. It's very interesting. So the next question I see popping in is, how much CLI knowledge is required as a solutions architect? None. We don't build anything. We don't touch the technology. We don't code. We don't configure. Now, what you need to understand is, how do I design a system? So, well, you don't need to know the CLI at all. If I asked you and said, we've got an organization, we have 200,000 remote access employees. I need you to design a secure solution to allow those 200,000 remote access employees to now work from home. That you would need to know. You'd have to consider the security, the identity management systems, the types of VPN concentrators that could handle those kinds of things, where you'd put your VPN concentrators, where you need your routing, and you need to understand how to design that. But we don't touch it. There's no CLI. We do not touch the tech. And I do want you to get hands-on and learn the labs, but that is not our job. I just like doing it. And that way, if anybody ever has asked you, yeah, I've done it, I know how it works. But understand, people don't hire construction workers to design hotels. They hire architects to design hotels, because you don't learn how to design by building. So there's no CLI knowledge there. There is an in-depth knowledge of the technology, not CLI. But how does the technology work? How do we put some pieces and parts behind together? How do you make that demilitarized zone to make it sure? How do you architect your end-to-end solution? And it's much more about having a team of people that are going to do it, that are all experts in the things, and it's much more knowledge for you understanding how it works, not how to do it. The best example I like to get is, here is the CLI to configure BGP on a Cisco router. Config T. Router BGP 65312. Neighbor 192.168. Remote AS 65313. Neighbor 192.168. Activate. Or I think it was 1.3. Activate. Now, I just turned on BGP. That's it. And all turned on. That's the CLI. Now, as a network architect, do I need to know that CLI? Not at all. But I was a network engineer first. Now, when you do that, let's say you turn that on a router in Japan. That will affect a sales team in Cape Town, South Africa. By the way, it affects the traffic in that organization. That may have a big impact on an HR system that's sitting in California. It may also have an impact of a financial application that's sitting in New York City. So what you need to understand is how do those routers work? How do those protocols work? How do they talk to each other? What is the right technology to use to solve which business problem? But no, we don't use the CLI. And there's a good video of David Lithicum and I last week talking about an AI architect. For those of you that don't know, David Lithicum was the chief cloud architect for Deloitte. He was their head of cloud strategy. He's been an cloud architect like me, and all kinds of architects, but he's been an architect for 35 years. I asked him on this webinar, it's on our YouTube channel, and I said, When was the last time you configured something? And it's like decades, because architects don't configure. But we do have to know how the tech works and how those pieces and parts go together. Good question. What is the LLM behind this service? They can use any LLM they want, and that is their own LLM. But, there's lots of large language models out there. Now, the bigger question is, which one should you use based upon your business's needs? That's the bigger issue. And should you use a proprietary service like we're talking about, or should you build your own? If you build your own, what do you gain? Customization, flexibility, more business relevance. But what do you lose? You got to spend your time to build it. How much time do you when you build it? What do you lose from a business agility perspective? That's the bigger question. And in most cases, they may not publish some of these pieces of information. Do we have a tool that helps plan the architecture? Yeah, there's an AWS pricing tool out there on the AWS website. But you also have to understand that you need your information, because, the way you transfer data, it determines what things cost. So there's a lot of other stuff that's there. But AWS has a pricing tool directly on their website. And as long as you know your traffic models and usage patterns, you'll be able to use it. But if you don't know that, you're going to get something that's very far from the reality. If there are so many architects involved in a big architecture, then the architect role becomes that of a product and sales manager. Not at all. Here's what a sales manager does. They manage 5 sales reps. That's what a sales manager does. The sales rep is the person that owns the sale. They own the pricing discussion with the client, for example. And a project manager, you're going to be working with lots of project managers. So let's say I get an RFP response, a request for proposal from a client. Now, the request for proposal itself could be 300 pages long, and each of questions, and each one of those questions could reply 1 to 3 page answers. So now, what do? You're going to have that lead architect that's going to go to the company. It's going to go to the management and say, I need these people, these people, these people, these people, and these people. And they're going to say, why do you need these people? Because there's a cost to these people. And you will talk about the opportunity that you have, the financial opportunity, and what you think you can get. And by that, you will build a business case to show this is a $200 million opportunity. And I'm 70% sure we can close it. So that's your expected value of the opportunity. You point that 0.75 times that, whatever you think that is, say 200 million, because you think you're going to win it with that level of confidence. And then you're going to show that I need this many people, and it's worth giving me 4 or 5 million of people for this $150 million opportunity. And your managers will give you the people. Then you're going to be creating a design, and you're going to basically delegate certain things out. Now, do you have it in you to go out there and ask 50 people every single day, all day long, did you turn in your document? Did you turn in this page? Did you turn in this page? Did you turn in this page? Do you have the ability to drive people crazy and be effective in your job? So the answer is not. So you basically create the strategy, and the project manager goes out there, the taskmaster, are you done? Are you done? Are you done? And that way they get to be the bad guy or the bad girl, as opposed to you. You become the soft, squishy architect, and they make sure the stuff is not forgotten. There could be a proof of concept where I'm going to go bring in 13 engineers, and there's a whole big project plan that's associated with that. I'm going to be managing the relationship, making sure I can solve the engineers' problems that they need. Like, you need me to go to the store? Do you need me to bring in dinner? Do you need me to bring in drinks? And again, the PM's going to make sure that all those things are done. Oh, step 1 is the wiring done? Good. Okay, step 2, what's necessary? Step 3. So you'll build the plan, or help the PM build the plan, and they will keep track of it. So no, there's going to be lots of PMs absolutely everywhere too. It takes huge teams of people to really deal with these kinds of enterprise architecture. And if you don't, you end up in the sad situation that 70% of all technology architectures fail. So hope that helps. In order to get certified, is it enough to watch these videos and practice the labs? Yeah, Lots of people have just used our training, but I'm going to recommend one thing. I'm going to recommend you get a practice test. I am. Because the hardest part of an AWS exam is not the questions. They're pretty easy. It's the way they ask the questions. They're very wordy. They're a little bit cryptic. They're not straightforward. That's the challenge on AWS exams. So I recommend getting a good practice test and practicing a good practice test, 600 to 800 questions worth, and go through it again and again. And when you can score like a 95%, you should be good to go. But I don't want you memorizing the questions and the answers per se. I want you each time where you don't get a question right to go see why you didn't get it right, and then go look up all those other answers and say, okay, this couldn't be right for this reason. This couldn't be right for these reasons. And that way I want you to build your knowledge on it. But yeah, passing the exam won't be hard. Okay, let's go back to the content. So I know you're awake. Let's do this. So if you're enjoying the content, please give it a like. Subscribe, hit the bell to be notified of new videos to help you. If you've just joined us, we've got some free AWS labs for you to do, over 40 of them. Some of them are really, really good too. Some of them get pretty technical, but download them, do them on your own time, getting hands-on experience, getting used to the technology, getting a feel for the technology is great. So, but you can do them at any time you want. These 2 weeks we're spending completely focused on trying to give you guys some knowledge here. Hope you guys are enjoying it. Let me know you're awake by giving me a hashtag AWSSAA. And then we'll get back to Amazon Polly. So, actually, we finished Amazon Polly. So let's get back to Amazon Rekognition. I was kind of excited to talk about that one. So we've got lots of types of technology to analyze information. So if I was going to give a presentation and I was going to have somebody that's a high-profile presenter, and they were going to give a massive presentation, maybe someone is trying to launch a new company, and they're trying to raise, $75 million. I might want to use some AI in the sentiment to talk about it. And when somebody talks about something that's not exciting, get them to stop talking about it and maybe pivot the conversation to something that is exciting that company's doing. You might want to be looking at that office, saying, audience, say, oh, what's going on? These people are happy. These people are not. So that's the kind of things we're talking about that, can help a business do things better. We're also talking about going out there and being able to look through the security cameras in England and be able to predict where a problem is because they're looking at something. We're talking about giving a speech and after the speech, being able to analyze the audience responses. We're talking about being able to mine through a lot of data and say, customers really like this product, or they really don't, or they're happy with this, or they're not happy. Or new branding messages that's coming out. Does this resonate with you? And you see people looking like this. Even if they say yes, the body language is going to give you some information. So you want to analyze that too. Sometimes people don't say what they mean. So recognition, and there's a lot of cool tools that you can use to do this from a deep learning perspective, will analyze video. So it gives you the ability to analyze a video, analyze it, and provide, some recognition of what people are doing. And lots of good things you can do from this from a business perspective. So the recognition itself can look at thousands of objects. And it can look for certain things. It could be like a car or an animal or a cat or furniture. It can look at scenes and say, this is a beach scene or this is a forest scene inside of an image or video. It can detect activities and actions to see if someone's running or jumping or dancing. It can look at their facial features and read the body language to give you some knowledge of what people are really saying. It can also do facial recognition. So you might be looking for something, and this can scan through lots of film and find that thing for you. So maybe you're looking for a lost child, and you've got facial recognition, and all of a sudden the child pops up on a camera, and you can find that child and give it back to the parents, for example. It could also be used to find someone that's deemed a risk to society. I'm not saying they should or could be used. I'm just saying they could. I'm not saying they should or shouldn't. I'm just saying they could. It could also say look for people. So what if you find that a product's being worn by a celebrity on their social media page? Well, that might be something that could be good for your brand that you may want to talk about that celebrity. Maybe they could be a rep for you, for example. So lots of opportunities here. Content moderation. It'll detect if something is inappropriate, and that can help maintain safety and compliance. And can track things, objects. So we talked about the features, and I gave you some use cases. So identifying stuff in content. You want to be able to look for something in a background. Maybe you're going to be working internationally, and maybe you've got these offices, and there's maybe something on the back wall that's okay in your culture, but not okay in something else, and you may want to remove it. So being able to look for that kind of stuff is a great place to use something called Rekognition. Retail and e-commerce. So here's a place where a product search can be, augmented by, say, images, because this can search through images. It could be used to create a personalized shopping experience, maybe with a visual search or some recommendations. Lots of opportunities in the surveillance world with this because of the facial recognition. And also you can kind of automate the detection of, say, things that don't look right. So there are certain patterns of behavior that tend to look suspicious, and you can set this up. For example, if it's 99 degrees outside, people typically don't wear a large winter coat and covered from head to toe with gloves and feet. So I'm not saying the person's a bad person or not a bad person, but it's not normal. So you may want to look for things that are patterns of behavior that are anomalies. Likewise, if it's negative 20 degrees outside, you expect people to wear clothing. So they can look for things that are patterns of behavior that could be indicative of something's wrong. Maybe someone's sick and needs help, but it'll give you information. In healthcare, because we're looking at images, so potentially we could use it to augment it with images if it was trained properly. Or lots of times in hospitals, people get lost. Yes, it's the patients that are called elope. They just disappear and you don't know where they went. So being able to find people in their hallways might be a good thing. Advertising. So companies can go look for their logo in videos. They can basically optimize where they place their ads based upon visual analysis and some understanding of people and the way they use it. So how do you set this up? Well, you go to the management console like anything else, or you could use the CLI or the API, and you get started with Rekognition. You choose what you wanted to do. Do you want it to do object recognition, facial analysis, text extraction, what have you? You then analyze the images and videos, basically meaning you upload them, and you specify what type of analysis you want, meaning do you want to extract text, or do you want to detect faces? You review the results when you're done, which are going to include what it detected and what have you. And then you're going to use, they're going to give you provided confidence scores, and you're going to use that to filter results. And you're going to look at it and see, is it really what you want? Then, if it is, you integrate it with your other applications, and then you monitor it. And like anything else, you optimize it. You tune it, you monitor it, you tune it some more. And that's how we constantly improve quality. So how do you make this better? How do you get the results better? Well, our AI is dependent upon data, right? The better the data, the better results. So if I want to opt to give it images and my images look horrible, meaning they're all grainy and their stuff isn't right, the Rekognition won't work as well as if you've got good images. So try to use images of good quality and good resolution. Try not to overly compress things or use low resolution images, because if you do, the results won't be as good because your data source won't be as good. Leverage custom labels. So Use custom labels to train models in your specific objects and scenes for whatever the relevant results are, and regularly update your custom models with new label data because you constantly want to maintain or improve your accuracy. Make sure you use it with integrated security features. That goes without saying. At minimum, use the AWS key management encryption. Use IAM at minimum. Now, when we're dealing with these types of things, let's talk about anonymization and data minimization. When possible, anonymize your data. So get rid of the personal identifiable information to protect user privacy. For example, maybe blur faces in images or redact sensitive information before processing it with Rekognition. Because if you train it with stuff that you don't want people to see, people will see it. You also want to do what's called data minimization. Like anything else, you only need whatever you need and nothing more, like the principle of least privileges, if you will. So I want you to collect and process the data necessary and only the data necessary for whatever your use case is. Avoid retaining personal data longer than needed, for example. So make sure you've got good data retention policies and you know what they are that are appropriate for your use case. Utilize the confidence scores. So look at the confidence scores provided by Amazon Rekognition to filter out and prioritize results. Set appropriate thresholds based upon what your application's needs are, because at some point you can go real accurate, but it affects your performance. You're going to have to choose where you need to be. So let's talk about another AWS or another AI service within AWS. That's going to be Amazon Textract. And that's another AI service that's going to go and extract text from handwriting, scan documents, what have you. So we used to use something called optical character recognition, and that could identify, letters and things and content. But AI can do a better job of it depending upon how accurate it is. So it can extract data from printed text, handwritten text, structured data from documents, see stuff and images. So it's pretty good because it's AI based at being able to pull text out of whatever you're looking for, whatever your source is, if it's a good source. So it can recognize tables and forms and extract that kind of information out of it. Can recognize handwriting. I don't know if I can recognize my handwriting because I've got medical handwriting, but it can recognize handwriting. And it's multi-language. So at the time we researched this, it supported 6 languages. So where might you use something like Textract? Well, think about automating data entry. Companies pay a lot of people to just put stuff into the computer. But if we can get AI to be accurate enough and pull out the information, or potentially as accurate as people are doing data entry, we can do this with the technology, and those people don't need to be doing that. Maybe we can relocate those people to do something else that's beneficial for the company. Document processing is another use case. So processing invoices, receipts, contracts, that sort of thing, business documents. Content management. So this will make documents more searchable and easier to retrieve. And it's also going to help out in auditing. So you figure when an audit comes in, or a compliance audit, or whatever that is, if you can pull data from a lot of data, you'll be better prepared to give information when it's requested. So let's talk about how to set this up. Obviously, you need an AWS account. You'll have to create a IAM role with permissions to use Textract. You'll get the Textract from the management console. You'll upload your documents to basically an S3 bucket, which will then, you have to set it up to call on the Textract, on Textract. It will then process the results. And there you go. So we'll talk about Amazon Translate. And Translate is a service that provides translation from one language to another. It uses AI, and that helps it become more efficient and accurate in real time. And because it can do this in real time, people of different languages can communicate despite language barriers. And this is something that's great, especially as the world becomes more international. So, Translate uses neural networks to identify and intelligently translate languages. So, it'll go from one language to another. Basically, there's two components here. There's an encoder here. And the encoder is going to read through the whole text word to process the meaning of the text verbatim. And that's how we set up the message. And then there's going to be a decoder that's going to use some form of a semantic meaning to translate the word for word text into the intended output language. So whenever we communicate, we typically do an encoding form, even human to human. If you actually study speech and communication patterns, they talk about encoding and decoding as well. But we take the words, call it something, and then give the user that something and then decode it to bring it back to what we started from. So that's the way Translate works. Oops. So it's a machine learning based translation. And as I mentioned, it would cover multiple languages, 75 of them. And you can create custom terminology lists. So you may have specific words or specific brands that need to be the same way and contextually and properly communicated. You can train this for that as well, custom terminology. You can do it real time. You can, like, if you need it immediately, you can do it in batch to translate conversations. So where might you use this? Well, how about your website? Here I am in South Florida, and all of a sudden, someone in China can see Mandarin, for example, off of my English-based website. One day I'd love to put my website in Greek as well. But what if, people in Greece could just read my English website and get it in Greece? Or someone in the Middle East or in Africa that speaks Arabic being able to get our website in Arabic. So I've always thought these kinds of things are pretty terrific. I travel the world and I know what it's like when you can't communicate well and what you do to try to communicate well, and seen lots of wonderful things. But the better we can have our communication, the less mistakes, the less challenges. So anytime you can translate between people, I think it's wonderful, especially as the world becomes more international. I mean, we're at a point where people don't come to the office to work sometimes. So it doesn't matter where they're at anywhere in the world, which gives people all across the world an incredible amount of opportunity. Customer service. Sometimes you call customer service and it's a little hard. But if we had some form of better translation, we have call centers all over the world. That could be a challenge. Or you could be like my family when they came to America from Greece. They didn't speak English. So we had a family member that spoke English and Greek always do the translation. But that made it hard when we weren't there to do the translation. So if you could just call and automatically someone can speak to you in your language, that's great. We could also use Translate in content management platforms. So we may have a company and it may have a knowledge base, and maybe it was created in the US or the UK, but we've got a big office in Germany. We've got another office in Paris, and we have another one in Brazil. And that's, multiple languages already. So big use case for that. Media and entertainment, another good place for this. So lots of times we watch movies and there's subtitles. Being able to translate it into multiple languages. So no matter, you could have your video and your movie in 50 languages, 60 languages, 75 languages technically. I always thought that would be kind of cool too. So how do you do? You set this up. You obviously have an Amazon account. You create an IAM role with permissions to use Translate. You call upon the Translate API. It processes your results. And there you go. So I will next discuss Amazon Bedrock. And I'll probably add a warning or a caveat as I talk about this, not about the AWS service itself. So it's a fully managed AWS service that enables users to build and scale generative AI. It provides access to foundational models from lots of AI companies. So your typical LLMs it could typically work with. And it can enable developers to easily integrate AI capabilities into their applications without understanding or having a lot of knowledge machine learning. So here's the danger. Amazon Bedrock is a great service and it makes it easy, super easy for companies to use AI. And that is the goal. If you don't know what you're designing because you don't have deep machine learning knowledge, it doesn't matter how easy is it, the chances of the design actually being right long term is slim to none. So just because there's a tool that enables you not to know a lot to be able to use it does not mean you should. Again, Amazon Bedrock is great. This is not a comment on Amazon Bedrock. This will be a comment on any service that says, here, you can use this, but you don't even need to know a lot about it. That's where the danger occurs. Not an Amazon thing, not an anybody thing. Because over 50% of cloud projects, and some authorities say 70% of cloud architectures fail. The tech works, but they don't drive transformation, meaning people are spending money and getting nothing back. So just because it's easy to do doesn't mean it should be done without being well thought out first. So Amazon Bedrock has access to lots of the LLMs there. Anthropics, like for example, like Claude 3.5, they're out there. Amazon has some of their own models. Stability AI has some. So there's lots of good models that you can use those. Models for text generation, models for text images, and why there's lots of good LLMs that run with those. It's fairly customizable and enables users to fine-tune and customize models for specific use cases and improve and tune the accuracy and relevance of the results. It's going to scale because it's a cloud provider systems, which are going to be running on their systems, which they typically have lots of excess compute capacity. It's a build it and they will come. There's a movie in America, I think it was called Field of Dreams, build it and they will come. Well, that's what the cloud providers have done. Because Bedrock is an AWS service for AWS stuff, it tends to integrate very nicely into other AWS things, such as S3, Lambda, Sagemaker. So where might you use Bedrock? Content creation. So you could use it like you would a ChatGPT to generate, high quality text or images or content for marketing. They say so. You can use it for social media. I don't recommend using AI to create social media content. You're creating content for social media to show who you are and what is your brand. If it's AI and everybody's AI sounds the same, what brand are you building? Bedrock could work out well for customer support. Lots of AI chatbots or virtual assistants you could create with it. You could use it for, say, as a recommendation engine. Maybe for a retailer, you can add a recommendation engine which sends recommendations on that person. While you're here, go check this out. Any kind of data augmentation. So you can look at the data and then generate synthetic data out of it. You can now prototype new ideas and test it out in a generative AI environment. So, like anything else, it's a generative AI, but it's an Amazon branded one, which works with multiple models behind the scenes that you can choose from. So, how would you use it? You'd sign up for an Amazon account. You would use one of the foundational models you would choose from with with Bedrock. You then customize your models and you'd integrate it to your applications. Most of these AI services are not in the Solutions Architect Associate. More of them are in the Solutions Architect Professional, but you never know exactly when these things are going to pop in, so I'd rather give you more preparation than you need. Let's talk about the next AWS machine learning artificial intelligence service, Sagemaker. And that's going to be a fully managed service from AWS that enables developers and data scientists to build, train, and deploy machine learning models. Now, obviously, they can create their own models on GPU-enabled instances or CPU-enabled instance basis the models, but this is a managed service. So one of the things that would be a feature of this is it comes with a integrated Jupyter notebook. So for the lots of people use Jupyter notebooks to basically explore and visualize data, and that service is available with you here. It works with, the main algorithms people would use. So you could customize your own machine learning algorithm to run on any server you want with TensorFlow or PyTorch. And Sagemaker will work that with you. But of course, it's a managed service versus you managing your systems. It supports MXNet and others. It has lots of algorithms for common tasks that you might use these types of frameworks for, like classification, regression, clustering, and recommendations. It enables you to tune your models and find the best version of the model by searching through lots of different tools and parameters. It supports some fairly distributed training, so you can train on a large data set with multiple instances. It's pretty easy to set up. So it's almost like a one-click deployment to pretty easily deploy models in your environment. You can create HTTP endpoints for predictions, for example. So it's easy to use. So where might you use SageMaker? Well, it's an AI tool that runs the more common, AI models and the tools that are out there and frameworks. So you might use it to go examine sensors to see when equipment's going to go and predict it so you can fix it before something fails. You might want to use it, say you're a bank, to identify fraudulent transactions and patterns of behaviors that feel like an anomaly. You might want to use a tool like this to look at customer insights and understand consumer behavior and give you some insights on what your customers are, what they're talking about. Potentially, this could be integrated into a healthcare environment, assuming all the regulations and things were done and you knew it worked, where it could analyze patient data and give their physicians, hey, here's something we notified. Maybe you should think about this at your next visit. So pretty much the steps to use this would be to prepare the data, because if you've got bad data, you're going to get bad results. Build and train your models, tune your models to optimize them, and then monitor your models, and then optimize as appropriate. So we'll briefly touch on Amazon Personalize, and that's going to be another machine learning service to kind of help create real-time and personalized recommendations to your users. So you're a business and you want to give a tailored experience to your users based upon user behaviors or preferences. So I had a cat that got stressed, so I was searching all kinds of things to relax the cat. If they saw me in a cat in the store buying cat treats and cat toys, is your cat stressed? If so, look at these new cat pheromones we have. Look at these cat stress balls. I don't know, but anytime you can personalize it and make it a better shopping experience, typically speaking, the customer is happier and the store earns more. So these are some of the things we can do with Amazon Personalize. It's going to give those really nice personalized recommendations. Lots of recommendation types, product recommendations, personalized search results. So lots of cool things you can do. You can also do it in real time. So while someone's in your store, you can do something like that. So really what it's doing is it's going to automate some of the machine learning for you. It's going to have some data pre-processing, some model training and tuning. It helps you pick the most appropriate models, for you to use based upon your use case. But again, you're still going to have to test this and see if it works. Because it's made by AWS, it's going to integrate into AWS things very nicely. So may integrate nicely into S3 or object storage to pull your data. Integrate with, say, a Lambda function or Cloudwatch. It's going to tend to scale very well. It automatically scales to handle data sets. And it knows how to scale to basically provide good quality with regards to lower latency and throughput. So where might we use this? I mentioned some e-commerce environments by recommending things to the customer. Media and the entertainment. So periodically I log into something. I log into Netflix, and I got to tell you, it's pretty good at showing me what I thinks I want to see based upon the movies I've watched. I log into another streaming service, and it gives me recommendations, and it's like, are you kidding me? I don't want to watch any of these things, but thank you so much. So any kind of way you can do it in media or music. So you're going to keep your users engaged and keep them subscribers longer, that sort of thing. Marketing and advertising. The ability to personalize a marketing campaign to a specific type of user or segment of the organization's environment. That's pretty interesting. Because sending the same message to everybody doesn't necessarily work, because lots of different people think differently. Lots of different people have different preferences. And to be able to send personalized recommendations can mean that an ad is placed at a lower cost and it's more effective. Customer service too. So if we've got these tools and they've got the data and they've got the abilities, it can kind of personalize the way we support our customers to come up with, again, higher satisfaction. So let's talk about some best practices for Amazon Personalize. Use good data. It's artificial intelligence, so garbage in, garbage out. Include a diverse set of interactions and metadata to improve the recommendation quality, because you got to train it, and your data has to be great. Constantly update the data. You've got new data and new things to train it. Experiment with different recipes. So that's really what we're talking about. Try this thing and see which is going to work best for you. When possible, anytime you work with data, if you've got metadata or data about the data, it will make it easier for these systems to mine and make better recommendations. So leverage metadata if you can. The next one is Alexa for Business. And this is the Amazon Alexa tool, if you will, to theoretically improve the usability of a conference room by giving people some Alexa-like tools. If organizations and businesses were to use Alexa, for example, they would have them the ability to centrally manage these things and use them in a shared space like a meeting room or a common area, that kind of thing. We all know about Alexa. We know what Alexa does. So I think that's enough on that. But I will get into Amazon Lex. And that's another fully managed AI service. And this is about building conversations via, say, voice or text. Lex is basically for your chatbots, your virtual assistants, and it kind of uses that natural language understanding where it can read through text to understand what it means, can recognize someone's speech, and could create a speech type response as well. So natural language processing is how you read through. Natural language understanding is more about how do you understand the text. So that's one of its key features. Some other key features here is that it can recognize speech automatically. And it can literally look at the spoken language and turn it into text with good accuracy. And by that, it enables voice-based interaction of applications at some point to make them user-friendly or user-accessible, that sort of thing. It works with multi-languages. So you can build the chatbot in more than one language. It also has that content of custom lexia or lexicons or a custom vocabulary. So you can really tune the terminology specific to the business needs in the industry. So where might you use something like an Amazon Lex? Well, you may want something to, say, automate customer service inquiries, things like maybe an order status, account information, and troubleshooting. You may want to reduce this kind of a chat type device to reduce wait times. and maybe provide instant responses for more smaller things that don't require as much human-to-human interaction. You might want to create a virtual assistant that says to help you with scheduling things or set up reminders. Lots of times in a content center or like a contact center, we want to be able to put calls to the right person. And a lot of that is going to be based upon getting the right information from the person. If we don't know why they're there, we can't send them to the expert on this versus the expert on that. So there are times where getting the right call and being able to get it right will really aid in the time to fix a customer's problem. And by doing so, faster resolution means happier customers. E-commerce, we could probably use this as well to come up with a conversational shopping assistant. You're at the store, and my wife goes to the store and she says, I'd like to buy new shoes. And she says, sure, the shoes are here, but we've got matching handbags over here. I know that would make my wife happy. So basically, how do you set this up? You go to the management console and you navigate to Amazon Lex. You create a new bot. You configure the basic settings, including, let's say, the bot name and the bot language. You define whatever your intents are. So like you create the intent that's going to represent the user action. So order a pizza, for example, could be an intent. And then you'll define slots to capture whatever information is needed. So order a pizza. Okay, who are you? I'm Mike. What's your phone number? What's that sort of thing. So next thing is building and testing the bot. You build it, and does it work? Does it work well? Then once you know it's good, you can integrate it to your other applications. You deploy it, and you monitor. Monitor with, say, Cloudwatch, for example. Monitor the results. Is it good? So let's talk about some best practices with Amazon Lex. Maybe start simple. So begin with a small set of intents and gradually expand as you get feedback. First, focus on the most common and impactful, and then other things. So prioritize. Use content effectively. So maintain context throughout the conversation to give it a more natural user experience. Constantly improve. Look at the interaction logs, look at the analytics, and identify areas of improvement. Update the bot's training data based upon the feedback that you've seen. So tune it so users will be happier. And of course, secure your data. So implement any robust security on any data you have, and always protect sensitive user information. I think it's probably been enough time for me to go to questions. Tyrone, are there any questions for me? Any questions, Tyrone? In the stage of preparing for the Solutions Architect exam, what are the key components you should remember? So remember this. It is, how do I want to say it? These exams are basically almost, I want to call it a technician exam. Here's the name of something. Here's how it's configured. And yet they ask you more about specifics of the technology itself. So remember this. Most of it is going to be a cognitive answer. So you really need to understand the tech. What is it and how does it work? More than how to configure it for the exam. Now, if you wanted to be a cloud engineer, you have to be really good at configuring this. But for the exam itself, most of it are just multiple choice questions. Most. So you need to understand the core AWS services. So core services, especially at the junior level, are virtual machines like EC2 instances, storage like EBS, EFS, S3, lots of stuff on S3, basic questions on databases, basic questions on the VPC, like where would you use an NACO, where would you use a security group. There is questions on identity and access management, which we talked about yesterday. There are questions, typically speaking, on encryption and what it describes as security best practices. Now, those security best practices are going to be very basic. So if you know security, this is going to be much more basic than that. So this is not like a CISSP level. This is going to be very basic. Here's where you'd put WAF. Here's where you'd put Shield. Here's about a network access list. Here is a security group, that kind of thing. Very basic security. There will be questions with cost management, like when would you use this type of an instance versus this type of instance. There will be a bias on these exams towards putting things like serverless and managed services to be a lower cost. That may be a lower cost to the end customer. In reality, it could be much more expensive. So, and there should be questions on basic troubleshooting. So that's going to be your mainstream of it. Tyrone, we'll go to the next one. Why is Bedrock called Bedrock? What is the significance? So here's the reality. The marketing team chose the name. So from a marketing perspective, Bedrock means strong and foundational layer. So to basically look like you've got a strong foundation for success. But that's a marketing term. I don't really put any stock in what marketing people call anything. I focus on what is the technology in and of itself. What is it really? How does the technology work under the hood? How could I leverage that technology to help my clients? And when should I use it and when should I not use it? Whatever they call it is whatever the marketing people got paid to do. So I don't typically worry about those things. Generally speaking, there's so much fluff in marketing. And that's why we've taken S3 and called it object storage. That's why we got rid of EC2 and called it a virtual machine. Because by the time you're done with all this marketing, you don't even know what the technology is. And how do you architect what you don't understand? Good to see you again, by the way. Do you get billed for using AWS AI tools? You will absolutely get billed, and it can be very expensive very fast. So, and if you want to learn AI tools, where could you learn them? Do you have a computer with an NVIDIA GPU in it? Could you run the model on a CPU of your computer where you can do these things free? So lots of times it's going to be a lot cheaper to practice off of the cloud, and you're going to get much more knowledge about the cloud anyway. So you'll learn much more by taking a server, installing a hypervisor, creating your virtual machines, building virtual networks in a virtualized environment, setting up virtual firewalls, and really put the pieces together and learn how it works than you ever will by clicking a management console. On any of your PCs, you can use these same PyTorch, TensorFlows, any of those kind of models that we're talking about today directly on a PC, especially if you've got enough horsepower in that PC. So if you want to play with it, you don't have to go to the cloud to do it. The cloud is just going to be selling you the same technology you would ever use on a server anyway. So keep that in your mind. It's just going to be managed for you. Will the real world business partner support such experimentation? Absolutely. In the real world, they know this is going to be part of the process. We're going to take this. We're going to train this. We're going to take this. We're going to train this. Now, if that's included, that cannot be, it's going to be at a lower cost billing than with something else. But all businesses know they're going to need to do experimentations with AI. And that's the big difference to determine, the reality of the real world. I mean, even if we use these AWS tools, which are half pre-made, there's going to be lots of iterations to get it right. If we build these tools on our own, we could potentially build a better one that's more customized to us. But it's going to be a lot harder to build in many cases than using one of these pre-made tools. So yeah, there's going to be lots of experimentations. And that's why most architectures take a good year to design, because you're going to have to try things. And then, when you reach the kind of background like David Lithicum or I would come from, and you've done all these architectures and you've got a great architecture repository of here's what we've done for this client and here's the business flows in here and here's of clients and here's what I've seen and here's what I've seen here and here's what worked and here didn't work. And these were the 80% of our career where you had to go fix somebody else's broken architectures because they missed these things. That's when you need to understand how to come up with systems quickly. But AI model building, AI model tuning, AI model testing, that are going to be big phases of the architecture project itself. Being an architect, if you want to experiment, cost compare between managed services like Kendra Comprehend versus developing and deploying a model and its AWS endpoint SageMaker. So you will potentially have to have to explore both options if you're a good architect. And let's be fair, sometimes you would be surprised how much cheaper it is in the data center than the cloud. Surprised. For our architect students one day, I wanted them to understand the difference between reality and marketing. And we went to Dell and we priced out, one of the newest, coolest AMD EPYC servers. I think it had 384 cores and about 8 terabytes of DRAM, and it was less than $500,000. And then we converted it to, and that's basically one of Amazon's servers. And we basically converted that into virtual machines with a certain specific IOPS per month, which was less than they would have had on the server itself. And over the course of a few years, with like $6 million versus the $500,000 that we spent. So you'll have to understand it. And that's part of why it takes so long. We have to understand that actual workload. How much is it running? What is its utilization? How much is the training time that it's going to take to train them? How many GPUs do we need to do the training? Could we do it on a few? Could we do it on many? What is the speed that we need the model trained? And then we can start looking at all the components that go put together. So you're not going to be able to experiment until you know what the architecture actually needs to be, because you need to compare one thing to another exactly. So the biggest question is not this or this and what it costs, because on the surface, it might not get what you need. It's including all the data and all this, and honestly, that's going to take some time to figure that out, and that's going to take some experience with your clients. But when you actually know what you're working with to start from, then you can actually cost compare. But you can't cost compare otherwise, because how do you know? Is something not running at all, where it's cheap to use serverless, running periodically? Is it running all the time? Amazon thought they had a great idea by making Amazon Prime microservice-based and serverless-based. And then they went, whoa, this was a huge mistake, because they turned it back into a monolith and saved 90%. And that's just because you got to know what you're starting with. If they knew what they were starting with before they designed the application, they probably would have chosen a monolith in the first place. But it all goes down to lots of experimentations. Most of the architectures I've ever done, somebody made a mistake. So don't pick the tech. Don't experiment with the tech until you know how it's actually going to be used. And that's when you will find out what it will truly cost. For beginners, what are the steps to design the current project to do? That, Alam, is an incredibly good question. And here's the answer. And I'm going to say it this way too, because this is so important. If you wanted to be an airplane pilot, and then you showed me photos of you playing golf and learned how to play golf, would it help? There's a reason I'm asking this question. If you went to law school, would that make you an airplane pilot? And the answer is no. So the first thing we need to know is know what job you want. And if you tell me which job you want, I can tell you the correct projects. But the training and experience for a physician is different than an attorney, which is different than an accountant. And we need to know your end goal. Now, if you are an architect and you set up a bunch of WordPress websites, for example, as projects, and did a bunch of documentation on Linux, I'd say, no, thank you. You look like an engineer or an admin, not an architect. I would expect you to do architecture things, like create a thought leadership how somehow some new technology can make an impact on these businesses. That's something an architect would be called to do. Or evaluate some new emerging cybersecurity threat and how organizations could potentially protect themselves from an architecture perspective. That would be an architecture project. Now, if I had a cloud engineer, and engineering and architecture are completely different, I'd want that cloud engineer to build big projects in Linux and projects in Windows systems administrators, and I'd want that person to be writing Python scripts. I'd want that person to deliver Terraform scripts. I'd want that person probably to get some experience on OpenShift and Kubernetes. I would want that person writing some Windows PowerShell scripts. And you can say, wait a second, the architect we're talking about writing in presentations, and the engineers we're talking about building stuff. So the first thing is knowing what you want to be, and then determine what kind of a role it is. So architecture is a planning role. 90% of architects, if they work at a real architecture company like a Microsoft, a Cisco, an IBM, an Accenture, Deloitte, a KPMG, a Capgemini, a PricewaterhouseCoopers, a global bank, will not be allowed to touch the technology. So we are called for our expertise in business guidance. Okay, so for a solution architect role. So here's what I want you to do, Alam. I want you to download, Tyrone, pop the link in this, the link in the chat box to the How to Become a Cloud Architect document. And I also want you to attend our completely free How to Become a Cloud Architect webinar on Thursday. But if you were to give a presentation at a conference on something related to tech or a business solution, that would make you look like an architect. A architectural document or reference type in architecture. So here's one way that you could create security to protect against this kind of a problem. You know, after spending time analyzing all the data loss prevention strategies that are out there, here's a data loss prevention strategy that I found to work in many kinds of organizations. Note, this works here, here, and here, but should be tuned in this manner for finance, and this manner for here, and this manner for this industry, and this manner. And of course, then talk about the specifics of the different kinds of things. How would an investment bank do something versus a trading firm versus a traditional brick and mortar bank? And that's really what the architecture is about. So join us Thursday. But the key is making sure your projects show that you're doing what you actually be doing in the job. We write lots of thought leaderships. We respond to lots of RFI, RFP, RFQs. So writing, concise writing for an executive audience, business writing, that's going to be things for an architect. But I want you to come and join us on the free webinar on how to become a cloud architect. And we will go over the role. And guess what? After the role, after this webinar is done, here's what we can do. We'll be on Zoom, so you can ask me questions live. Turn on your cameras. We'll have a conversation. I'll do anything I can for you. And it's free. So I look forward to it. You said you're registered for the webinar. Can't wait to see you there. All right. So let me know you're awake. I like to be awake. My wife tells me I bounce off the walls, that I drink too much coffee in the morning, but I like to be awake. So let me know you're awake, alert, and aware by giving me a hashtag AWS SAA. If you haven't gotten our labs, go get them and go do them. They're completely free. If you're enjoying the video, please give it a like. Hit the bell to be notified of new video, and subscribe and hit the bell to be notified of new videos and new things we have to help you in your cloud computing career. So now let's talk about yet another AWS service that also is AI based. And we're going to talk about Amazon Forecast. And businesses make a lot of forecasts. And one of the main things that businesses are using is AI to make predictions or inferences for the future. And Amazon Forecast is a service to help you do so. So let's talk about ways where business would use forecasting technology. So a business, let's say they produce a product and they need to sell it, right? If they produce too much of the product, they have inventory, and they probably didn't have the money for the inventory in the first place, so they typically have to pay financing charges on the inventory. In addition to that, many products spoil. For example, if we've got a company that makes computers and they make too many computers with this year's processor and GPU, As soon as there's a new NVIDIA GPU next year and a new Intel processor next year or AMD processor, those computers go down in value. But if they don't produce enough, when people want to buy it, they won't have it and they'll lose sales. So demand planning in business is huge. And a service like Forecast can help out a lot with that. Resource planning. So how many people do you have working at your restaurant? You typically on small days have very few, and on big days have a whole lot. What happens when lots of people come in and you don't have the staff? So, those kinds of things are the kinds of things that businesses need to forecast all the time. So, kind of keep that in the back of your mind. So, Amazon Forecast, it's based on machine learning and it automates the process of building, training, and deploying models. It selects what it thinks are the most appropriate algorithms or parameters for you. And it can be accurate in the way it generates reports, especially if the data you give it is accurate. And it can use lots of different forecasting models. It's got lots of algorithms built right in. And it helps with, say, time series forecasting. So if you've got data bets with dependencies, it can look at what can happen now for you 3 months from now, 6 months from now, and that kind of projections. It'll help with give you tools for cleansing your data, transforming and preparing your data to use it. Because the better your data is, the better your accuracy will be. And it will integrate with a wide variety of sources that you have on AWS, like Redshift, S3, any of the databases. So where might you use this? Well, inventory management would be a good use case. So if an organization can predict and optimize inventory, it can save financing and it can reduce its cost to carry that. Workforce planning, as I mentioned a little bit earlier. So how do you have the right number of people? Ever go to a hotel in the middle of the week or on a weekend where they're not expecting a lot of people and all of a sudden you get there and then lots of people and then you can't find somebody? Because they didn't workforce plan. So, where they planned, but they weren't accurate. So, any kind of way where we can analyze data and notice maybe you need more people on these days versus these days, that kind of thing can help an organization staff properly. Financing. Whoa. This is a place where businesses need a lot of predictions. So, what money do they think is coming in? What expenses do they think they have? What's the cash flow going to be coming in? Do they have the cash flow to pay what they need? How do they run their company? Are they overly invested? Do they need a line of credit? So, for any kind of forecasting here can really help a business. How about resource allocation? So, what resources are going to be necessary for a product? There's the estimation that we do, and then maybe that needs to be optimized for material, equipment, and personnel. And this can help us there as well. Sales forecasting. So, if a company doesn't know what amount of money is coming in, it'll be in danger of going bankrupt or in danger of losing money and hemorrhaging people and having to lay off. So on bad things happen. So the more accurate a company can forecast its sales, the better it will do. So how do we manage Amazon forecast and make it run right? Well, we use good data because if we train it on bad data, we've got garbage. So we want good, accurate, complete data. We got to constantly update our data to maintain our forecast accuracy. If there's external data coming in that we can also use, they can help with our forecast accuracy, like interest rates and what they are, a government spending program, a tax cut, a weather forecast, market trends, an inverted yield curve, what have you in the bond world. These are kind of things that can predict either things going well or things going really bad. And that can help a business to dissect economic information and make better predictions for the future based upon what it sees market-wise going on. And lots of organizations have economists for these reasons, but the more tools the scientists have, the better they can do, or even the social scientists in the case of economists. So best practice-wise, really evaluate and tune these models. So you're going to tune it, and need to tune it again. There may be lots of algorithms. You may need to try different ones. Look at the accuracy. If you're getting good forecast back and it's right, this is great. If you are not, fix it, because you don't want to make information on bad. You don't want to take bad information and make decisions on it. Set it up. Basically, it's about prepping data, uploading the data, creating a data set group, and training a predictor. And that's about selecting the algorithms and parameters, and then monitoring the data, and then generating your forecasts. Now, when we know the forecasts are good, we integrate them into our applications, and we're good to go. So we have completed the section on AI tools in Amazon. So if you were here when we talked about databases, we talked about queuing systems. And we talked about how queuing could help a database. But now we're going to talk about the Amazon managed queue. Now, understand there are queues like Kafka, which you could use in a multi-cloud environment. And if you're in a multi-cloud environment, you'll probably need to use something like Apache Kafka. But if you're just in AWS and you're looking for an AWS proprietary, fully managed solution for some reason, Amazon SQS is very simple, it's very elegant, and it definitely fits the bill. So why do we use queuing systems? We use it to decouple and scale systems. If we've got microservices-based applications, distributed systems, we need to be able to store our messages before they ultimately get to their goal. We could also use it to slow or reduce or smooth out the write load coming into a relational database. So Amazon has their own fully managed queue called SQS, or Simple Queuing Service. And it is a message queuing service that provides temporary storage of messages. And it can keep your messages in the queue for up to 2 weeks. And by doing so, it enables you to right-size your application. So instead of building your database or application for peak performance, you can build it for an average performance, and then those messages can be added to the system when it's ready. So right-sizing applications is critical in the cloud, because if we don't right-size them for the cloud, we're going to get scary cloud costs. Something else that's kind of cool is you can leverage it for auto-scaling. So you could see I have a certain number of messages in the queue, add capacity, add another virtual machine. And by using it, you're going to have some form of communication in your multi-tiered applications, maybe middleware or some kind of messaging middleware. So SQS can function as that. Now, when we've got queues, we've got two kinds of queues that we're talking about. We've got a standard queue, and here's what a standard queue is. Messages come in, and they get taken out as fast as the receiver is able to. That is a standard queue. And that's going to be the fastest option. And here's the reason. The first message may be tiny. The second message may be huge. And the third, fourth, and fifth message may be super small. So it's quite possible that the first, fourth, and the fifth, fourth, and fifth can be sent out quicker than waiting for the first, second, third, fourth, and fifth. So when we go through this, the messages come in, but the order is not going to be guaranteed out. But that's going to be the fastest performance. And every message will be delivered at least once. But messages may be delivered out of order. The alternative is we can use something called the FIFO queue, our first in, first out queue. Meaning, I go in first, I go out second. Cindy goes in next, Cindy goes out next. Mehdi comes in third, Mehdi leaves fourth. The Gelly comes in fifth, the Gelly leaves in sixth. So it's basically going to be sequential, first in and first out. We also have the option with SQS, and we should typically speaking, create something called a dead letter queue. So what is a dead letter queue? So it comes from the postal system. Basically speaking, if the post office tried to deliver a message or an envelope or a package, and they couldn't find where it went to this queue, and it was called the dead letter queue. And that way, if someone came in and said to find it, at least they could go through those packages. Same thing in tech. We may have a queue that should be sending a message in, but what if it's not delivered? Do we want to lose that message, or do we want to put it somewhere like the post office did? Well, we do just like the post office did, and we create that dead letter queue where we can retain a message if an error occurred. Now, let's think a message coming in could be a sale order. We don't want to lose that. Maybe we find it a day later or 2 days later and process it and send the customer, here's a special coupon, or here's a percentage off because you had to wait 2 extra days or something like that. So let's talk about some good benefits of SQS or any queuing system. Well, in this case, it automatically scales for you because it's a managed service. Where if it was your own, say a Kafka queue, you'd have to manage your own servers and, as necessary, add capacity to the servers. It tends to be reliable. These are pre-made systems by AWS. They tend to run well. It may be very cost effective because you only pay for the messages you send and receive or delete. It may also be completely uncost effective if you've got too many messages going through it, in which case you should build your own. So any time where we talk about cost, it's critical for us to know the utilization pattern to understand what's going to be best for us. And it's pretty easy to use. It's got a simple API and console interface. You can get to it pretty easy. And here's a way you may actually use something like this. So you may have a customer, let's say you've got a 3-tier website. They place an order. First, they visit the web server, then the app servers run their business logic, and then the order goes through. And you have a queue on the way to your database to make sure your database doesn't get too many messages too fast so you don't lose any. And maybe you also send it to this simple, one of the simple messaging service like SES or simple email service to then send you a thank you email. That would be a use case where we'd use something like SQS. So how does this really work? The message will go from the computing platform to the queue. And the message will stay in the queue until the receiver can take it out of the queue. Then the message is pulled from the queue and it is no longer there. Message can stay in the queue for up to 14 days based upon the configuration that you choose. And the message will be pulled from the queue as it's processed. So here's the way I always visualize these in my mind. In a queue, you've got people that are sending the message into the queue at the top. When the receiver is ready, that message gets taken from the queue and sent to the receiver. And then finally, the message is removed from the queue. And that way the message has a temporary place to store the message until it gets to their end destination. So where might you give me some use cases of a queuing system like this? In microservices. Anytime you've got a microservice-based application, you've got all these little independently scaling things. So it can help you decouple them and get the messages to who they need to be. Same thing, we might use it in a serverless application. We could have something in an SQL, in an SQS trigger, say a Lambda function to process a message. We might use it in, say, batch processing. We can collect a bunch of messages from the queue and then process them accordingly as fast as we could. We might use them in order processing so we don't lose orders as they're being written to, say, the database or the transaction log. And we could also use it for, say, asynchronous processing. So we may have a lot of email notifications and data processing and other background jobs that this can kind of fan out or connect to. So when might we use this? So if want to deal with, say, capacity planning, if we've got a database that can only handle so many messages being written, but we've got a queue, if the database is a little bit too small, it might be okay because they might sit in the queue. And if we've got periods of peaks and valleys, we may be able to get away with a smaller system. We don't want messages to be lost, right? If a company is doing sales and they lose sales orders, that's not a good thing, right? So we could use it there. Also very good to use in, say, auto scaling. You got a web server application, all of a sudden a bunch of messages are coming into your queue, and go expand, auto scale, and have more capacity when you need them. Where might you integrate SQS? Well, in any kind of database, maybe to trigger a Lambda function, maybe to process a message on an EC2 instance, for triggering events that maybe send messages to, say, SQS. So now we're kind of in other message queue world. So there's another message queue that we can talk about, MQ, or Amazon Message Queue. And that's going to be a fully managed open source message broker for Apache, say, ActiveMQ or RabbitMQ. And what's happening here is AWS is making it easier for you to use these open source message brokers, because Amazon's going to do the main maintenance on these things. So again, this is MQ is a pay-as-you-go pricing. So users are going to pay for the time the message broker instance runs per hour. So, and storage will be billed monthly. So pay-as-you-go could be great if you don't use it a lot. If you use it a whole lot, it might be cheaper for you to manage your own infrastructure. But again, this is a choice, but you can't make this choice until you actually know. AWS calculates something like this. They look at the total sum or number of gigabytes you used each hour, and then they divide it by the number of hours in the month. And that comes up with a value they call GB months, but they also charge data transfer fees as well. But the key thing to remember here, it's a managed service. So you don't have to think about managing your own message brokers or patching them or updating and maintaining the underlying servers of the system product, because it's managed for you. And it supports popular message brokers like RabbitMQ or Apache ActiveMQ. And because it's managed for you, they typically run these across multiple availability zones. So it's relatively highly available. It integrates very nicely with AWS things like the identity access management systems or the key management systems. Because it's managed, they always auto scale most of these managed things. So it will scale as needed. Now, again, if it scales too much, it might be cheaper to build your own. But knowing that it'll do it for you when you need it, for giving you the chance to figure out the best pricing long term, again, is something great. And it's pretty easy to monitor because it'll integrate with Amazon Cloudwatch. And you get some fairly detailed logs and metrics for visibility and to see what's going on. And because it is an open source tool, it makes it easy for a customer that's already in their data center or another cloud using an ActiveMQ or RabbitMQ workload. So minimal disruption along the way in. So where would we use these? Lots of time in a microservices communication, because it'll facilitate the communication and coordination between microservices. It enables asynchronous messaging, which again enables discoupling of services. It's great in event-driven architectures, and event-driven architectures that if this happens, then do this. If a user puts something public in S3 and it shouldn't be, kick off a Lambda function and go fix it. It's a message queue. So anytime you want to decouple your applications, you can be thinking of something like this. So where might you want to use MQ? Well, if you're going to have a legacy system and traditional message brokers, or you're going to be in multiple clouds you might want to use something like this because it's open source. So how would you set this up? Well, for the most part, you're going to go to the management console and go to the AWS MQ console and create a broker. And that you'll figure the type of instances and storage and network settings that you need. You'll configure your security settings like your VPC security groups and your encryption. You'll configure your IAM and authentication systems and your IAM policies. You'll connect it to the broker. You'll monitor and manage your systems. Let's talk about some best practices. So deploy these message brokers in multiple availability zones. So when one data center fails, you've got another one. and obviously configure automatic failover. So if one AZ or a data center fails, it'll go down. Secure it. So use strong IAM with this. Enable encryption at rest of your storage. Enable encryption in transit for critical and private information. You're putting them in your VPC, so make sure it's in a private subnet. Make sure you've got an access control list or a network access control list, only allowing the IPs that are supposed to use it. Use strong passwords, the same things you would do for most things, but also make sure your network is secured through whatever other devices you may need as well, or services. So monitor your usage metrics, because you may need to know when to scale the broker, or maybe it's time to get off of this and build your own one that's not managed, which is going to be cheaper for you once you understand what you're paying based upon the use. Back up and recover your system, your information. So regularly back up your broker configurations. And, use it. It's a great, if you can do a migration, plan it ahead of time. So use these migration tools, but plan it and test it and see it long before you just jump and migrate. Okay, so now we're going to get into another messaging service. And this is going to be called the Amazon Simple Notification Service. And that is going to be a managed messaging service to deliver messages between systems, or between systems and people. It's a messaging service, so we use it to decouple messages between microservice applications. We may use it to send an email or an SMS, or push a message to, say, a mobile device. It facilitates a publisher-subscriber model, which we'll talk about. And that's a lot like, joining a mailing list. You join the mailing list, and they push the message to the list, and then you get it. So it works on those types of things that can be used as well with publishers and subscribers. And when you deal with this, we typically have two components of it: a publisher and a subscriber. So a publisher will communicate by sending a message to something called a topic. And a topic is like the email list that you subscribe to. I always thought it was a mailing list. So here you can see a publisher will push this message to an SNS topic. Now, the topic itself could be sent to anywhere it needs to go. Maybe we've got this message being fanned out to multiple systems. One message goes to a queue, one goes to a Lambda function, one sends an email notification to people. Some features that you have with SNS is the ability to kind of manage your topics. So you can organize your topics to categorize the messages, meaning you can send some messages to some subscribers, but not others, kind of like good email software would enable you to do. It enables you to filter messages. So subscribers may be able to filter out messages maybe on an attribute in the message. Again, making sure subscribers can receive what they want, kind of like an email list. When you click, I don't want to receive this and this and this, but I'd still like to receive this. It's typically good at what you call durable message delivery. So it's going to store the messages that are going to be sent across multiple data centers or availability zones. So, if a data center goes out, you typically don't lose it. And it will retry the messages if the first attempt fails. So where might you use this? You might use SNS in event notifications. So you can do lots of things with this to maybe push a message to a phone or push in a message to an application. You may use SNS with regards to integrating various applications because it can help decouple microservices and distributed systems with SNS topics for inter-service communication. It tends to lead well into that application integration decoupling environment. You can ensure that a change here can trigger actions in multiple things that are dependent upon it. We might use it for monitoring. So we could have some funny things going on with our systems, and Cloudwatch may notice it. And then we can take that Cloudwatch event and push it to SNS to then notify or text, say, a systems administrator. We may use it for user notifications. So imagine this. You've got a realtor driving around with clients in the back of the car looking for houses. And as that person's driving, a new listing pops up and the realtor gets told, oh, here's a new house that you're a mile away that maybe you should consider. So lots of cool things we can do with something like this. It's basically configured by creating a topic, having the systems that need to subscribe to the topic, and then messages are published to the topic and the receiver get them. And of course, with any other system, you'll monitor it, see what's going on. Let's talk about some best practices with regards to Amazon SNS. Filter messages by message attributes. So define message attributes and categorize and filter messages. And that way subscribers can get what they want versus just everything, only relevant messages. Implement some good form of access control. So set up IAM policies to determine who can publish and subscribe to the content, because you don't want it going to the wrong people. Put in some very fine-grained permissions to enhance security. Again, going back to the principle of least privilege, never giving more access than necessary is to get the job done. Ensure reliable delivery. So maybe you combine SNS, the notification service, with the Amazon SQS or the simple queuing service to make sure that the messages are then sent to a queue to be delivered reliably. While we're at it, set up that dead letter queue that we talked about to prevent message delivery failures. Monitor and scale your systems. So if you're going to be running something like this, look and see what's going on. Do you have to adjust your systems for increased load? What do you need to do? How do you need to tune these systems to make them work? Now, when possible, set it up for secure communication. Encrypt the messages at rest and in transit. And use HTTPS endpoints for secure message delivery. Okay, the next service we'll talk about is something called step functions. So remember when we talked about Lambda? And we said a Lambda function runs, and then it's done. So if you had a logic where you wanted this to occur, and then this to occur, and then this to occur, you'd need to find some way to orchestrate. Do step one. After step one, do step two. After step two, do step three. And that's where we come into Amazon step functions. And AWS step functions is a serverless orchestration service that lets you coordinate basically these Lambda functions or things into a workflow of in order. Do this, first this, first this. So with step functions, you can relatively easily build and update applications quickly. And you can create what's called like a state machine, if you're familiar with a finite state machine, which is basically a series of steps that can be executed in order. And here's the way I've always visualized this in my head with the step function. You've got something you want to do, so schedule it. This thing happens, a Lambda function kicks off. Then a next Lambda function kicks off, and then another Lambda function kicks off. So that's a way you may want to use step functions. So one nice thing with step functions is it gives you a visual workflow, which makes it very easy for you to say this thing, and then this thing, and then this thing. So if you can see it, it's going to be much easier to develop, at least for most people. Because it's an AWS service, it tends to integrate very nicely with other AWS services like AWS Lambda, ECS, Fargate, that sort of thing. Because we talked about Lambda functions being stateless, step functions gives us the ability to manage state. So track the progress of each step. It also does some error handling and it can catch errors and define fallback states. So where might we use AWS step functions? Well, we might use it to orchestrate ETL workflows that extract, transform, and load workflow from, say, one source of data into maybe another database. We could use it to coordinate tasks, maybe data ingestion, then data transformation, and then data storage. We could be using step functions to orchestrate microservices. So we may have some fairly complicated interactions between microservices, and we can use step functions to manage that. So we've got a complex business process that's going to span multiple microservices. We can use it for that to help schedule that. We may want to do batch or stream processing. So we've got a lot of information that requires batch processing. This could be a good thing. So let's say I set up a video, kind of video I would record on one of my cameras. That it is a huge, giant video. I can go through a 512 megabyte video card in about a half an hour with one of the cameras that I use, easily. So I can't distribute that or stream that on the internet, but if I wanted to take super high resolution photos of my cat for videos of my cat for some reason, I might upload a half a terabyte video file. I could then have that kicked off, for example, to another processing engine to turn it into an MP4 file with an H.265 codec to shrink it down into something very small. I might then have captions burned into that video somewhere along the line, and I could set all those things happen to occur. I could do this with hundreds or thousands of videos at any one time, like you might want to do if you stream video as like a business, like a video streaming service, like to create your own Netflix or something to that effect. I can also do this batch and stream processing for a big workflow, big amounts of data that I might need to deal with. Got a lot of data. The data has been processed, and I'll kick it from one place to another place. Very good place to use this would be, say, application workflows, another use case, because you've got a lot of applications that have multi-step workflows, like an order process, account management, inventory tracking, and step functions can manage state transitions and error handling and kind of help us with all this. What if we had a machine learning pipeline? So we might want to orchestrate machine learning workflows like data pre-processing and then model training and model deployment. And we could use step functions to help schedule out those functions. So basically what's going on here is the person that's going to configure this is going to go to the management console. They're going to define the state machine. They'll create a workflow, which is step 1, step 2, that kind of thing. But they'll start it by clicking, create state machine. Then they'll add the tasks along the way. Add the workflow that you want it to be. If you know what it is, define the ARN or the Amazon resource number or the service function that you want it to go invoke or do. Test the workflow. Is one thing happening and the next thing and the next thing, is it doing it the way you planned it? If it does, then you deploy it, put it into production use, and then monitor and then tune along the way. Some best practices with step functions are to implement error handling and retries. You want some robust error handling, and you want a good retry policy. So make sure that you set that up. Break down as many complicated workflows as you can into something small and little mini state machines. And that way there are simple things that you're planning out each time. Really want to optimize this like anything else for performance. So optimize your transitions, specifically those state transactions, and task execution times to improve the performance of it. If we have the ability to execute multiple parallel things at the same time to reduce processing time or latency, let's go do it. We want to make sure that we secure access to the system. So use IAM roles and policies to control access to these new state machines you've created. Make sure that you're applying to the principle of least privilege. Monitor these things. So set up logging and monitoring. Really set up your Cloudwatch alarms and monitor execution performance. And then that's it with regards to that. So I think it's probably time, Tyrone. I'm going to see if there's any questions that are out there. If there are, we will answer them. If they're not, that's okay. We'll go back to the content. All right, I'll give it about 30 seconds, Tyrone. And see, and in the meantime, If you're having a good time with the video, please hit the like button. I would suggest subscribing to the channel, hit the bell to be notified of new videos because we have a lot of new videos coming and lots of things to help you in your cloud computing career. If you've not downloaded our AWS labs, are not downloaded or not signed up for them, so you can actually go through and work them at any time you desire, please do so. They're completely free. All right, we will get back to the content. And now we will talk about the Amazon API Gateway. And that's going to be a managed service provided by Amazon that's going to enable developers to easily create, publish, and maintain and monitor APIs at, for the most part, any scale. Some key features of the Amazon API Gateway is the easy API creation and management, RESTful APIs. You can create RESTful APIs here when needed, WebSocket APIs for typically two-way communication between a client and a server. It's going to integrate easily to any AWS things because it's AWS, things like Lambda, virtual machines, EC2 instances. It's going to, etc. So where would we use an Amazon API Gateway? Well, we might use it for backend services and the web and mobile applications. We may want to use it with microservices to expose microservices running on, say, AWS Lambda, ECS, or maybe some other platforms. We might want to use this API gateway in data processing. For example, we can use an API to trigger our data processing or workflow on another system. We may want to use it for third-party integrations to create APIs to basically connect to external partners. So what goes into setting up the Amazon API Gateway? Basically speaking, you have to define the API, including its resources and methods. Then you deploy the API to a specific area. Are you putting it into development? Are you putting it into production? So, and then, you're going to secure the API. You're going to put in, do we need any kind of authentication, for example? What is the authorization? What are we dealing with that wise? We're going to go monitor the API. We're going to look at it. We're going to look at the logs, look at the performance of the API. And we will update these APIs as necessary. The version and maintain these APIs. We'll briefly discuss AppFlow. AppFlow is a bidirectional service that's going to move and synchronize data from third-party applications. Maybe a SaaS application like Salesforce or Slack with AWS. So by doing so, you can create that bidirectional communication, that kind of integration without writing code. And to make this work, all that's really needed is to configure your data transfer requirements. And AppFlow, will take care of the rest because it's already been predefined. And this way, companies that use some of these SaaS applications, like potentially Salesforce or an Office 365, they can get data from multiple sources, which will enable them to basically aggregate that data, create hypotheses, draw conclusions, be able to pull information for the company's knowledge base. So lots of good things that can happen when we can get our data and synchronize our data and then analyze the data and do stuff to it. And AppFlow really improves the efficiencies of connecting applications and services because it's done without you needing to code. So is that a good thing? Well, if it fits your use case exactly, it is. If it doesn't, you might need a custom application, but this is based upon the business needs, not, the technology is selected after we know what the business needs. So AppFlow can help modernize data governance and move your data back and forth between the applications. So we might use AppFlow to quickly integrate applications, maybe to transfer data at a massive scale, maybe to help automate data security. Well, that was AppFlow. Now we're going to talk about AppSync. And AppSync is going to be a managed service that helps you build scalable, GraphQL APIs for real-time data queries, synchronization, and offline programming. This is going to simplify application development by making it easier to interact with multiple data sources through a single API, an API endpoint. AppSync goes back to using that publish-subscribe model, just like we dealt with SNS, to push or pull data from multiple sources. And a template will be created to define what data is going to be pulled from what sources. And then what do they do and pass to the user? AppSync is relatively a simple solution that enables lots of applications to be connected and synchronized from multiple sources, multiple databases, Lambda functions, and OpenSearch, what have you. And AppSync will automatically manage and update the data in the web and mobile applications. And that way it'll deal with real-time updates of the data, what have you. So makes it easy to get all the data from multiple applications and maybe transform it to the cloud or use it for multiple applications. Some key features here with AppSync is that it is a GraphQL API. So that means it's going to support, GraphQL, which is a very efficient query language for APIs. It'll enable clients to request exactly what they need, and that's going to minimize overfetching or underfetching of data. It works with real-time data AppSync. So we've got some good real-time data synchronization and updates. It enables features like subscriptions to automatically update clients with the latest data as it changes. It also has some offline support. So it's going to provide support for offline data synchronization. So if the data source comes online and comes offline, it knows how to work around that. And it can work with lots of data sources AppSync. Things like DynamoDB, Lambda, RDS, and all kinds of HTTP endpoints. From a security perspective, features-wise, well, it's AWS, so it's going to integrate directly into AWS systems like the IAM systems that you can use. It'll integrate into Cognito and other API keys that we might have for authentication and authorization. It tends to scale well because it's a managed service, so it'll automatically scale to handle the API request based upon your volume of traffic. And that way you've got relatively good high performance and low latency API operations. And it is a managed service. So think about, you don't need to build the provision. You don't need to scale it. You don't need to maintain it, which has its advantages. If you offload certain things to managed services, you can focus more on running the business or other forms of innovation. So sometimes a managed service is great and sometimes it's not. What is the need of the business? What does it best? So what kind of business benefits would AppSync provide? Well, because it speeds up development with a single API endpoint, it can enable businesses that are really deploying new applications faster, which could potentially be more opportunities for the business to earn or get better or stop losses. It can be used to enhance user experience. So because it delivers real-time updates, it can give a pretty good user experience. It could potentially, because it's pulling and pushing, reduce data transfer and processing costs, potentially. It makes it very easy to manage the data because it's providing that GraphQL API and you can query it. It's going to be very simple when you're dealing with those GraphQL type environments and databases. So where might you use this? Well, how about mobile applications? You might want to build a mobile or a web application that's going to dynamically fetch new data and update itself. By being able to constantly pull new data, that can enhance the user experience. Microservices. So, we might want to use it for microservices integration. AppSync can aggregate data from various microservices into a single API, like a unified API. And that will simplify the architecture and the data flow in some microservice-based applications, which can get fairly complicated. We might want to use AppSync with regards to IoT applications. So we may want to be able to build those kind of IoT applications. And yesterday we talked about things like weather sensors and driving cars and machines that are going to determine when they need to be repaired. So we could use it there. And because it takes real-time data synchronization, this tends to work well for that type of a use case. We might also want to create some data-driven dashboards. So maybe we create some interactive and real-time dashboards with insights and analytics. So you're giving companies leadership. Here's what's going on business-wise today. Here's what's been trending. And they can make decisions to do this or do this to make the business healthier. Let's talk about logging in AWS. And with that, we will talk about Cloudwatch. And Cloudwatch is going to be a monitoring service to monitor AWS resources, as well as other applications that you deploy on AWS. So logging, monitoring. So Cloudwatch will give you metrics to monitor your performance and troubleshoot issues. And Cloudwatch can monitor any kind of application you run on AWS. The thing to remember is we've got a couple of kinds of metrics, built-in metrics and custom metrics, and we'll talk about it. Visually speaking, here's how I think of Cloudwatch. Basically, use it to monitor. You collect all kinds of information. This system had a CPU of 85% and it stayed that way. Okay, maybe it's time to add up more servers or add a bigger system. DRAM utilization is too high. This type of a firewall is getting hit too many times, that kind of thing. Something's going on. Anytime you can pull information. So maybe your firewall is running on a virtual machine and the CPUs are too high. Maybe then to go look at some of the firewall systems, see what's going on. Is it a traffic thing? Is it stopping because there's a pattern of behavior hitting it that's hitting the CPU? Are you being hacked? Is it doing things in real time? Is that any kind of thing where you can actually look and see what's going on? And logging is not new. If you were a Windows systems administrator, you'd be looking at the page file to see if it's being used. And if the page file is being used a lot, you'd know that system would need more DRAM. So this is standard logging that we've used for 50 years in technology. But this is the Amazon thing that collects logs from Amazon in this kind of environment for you. So now you know what is Cloudwatch. So Cloudwatch has some built-in default metrics, which include CPU utilization, disk read and write in terms of the IOPS, and network utilization. So that's not a lot. Note, I didn't say DRAM there. I didn't say a lot of things, but the built-in default metrics are CPU utilization, disk read write ups, and network utilization. Like how much of the 2 gig, I've got a 10 gig link and I'm at 8 gigs, that kind of thing. But if you need more, you can add custom metrics. So you can look at the memory utilization on a cache that you might have or an in-memory database, because that's going to be critical there. You may want to look at the API performance of something or other metrics. So we can use Cloudwatch for that. It sounds like a hurricane is out there. So hopefully my power cooperates and my 3 internet service providers. Because sometimes where I live in South Florida, when we get these kind of monster storms, they all go out, at least for a short period of time. So Cloudwatch has some notification systems. So it can send a Cloudwatch event, otherwise known as Eventbridge. And that can send out an SP trigger to send out an SNS text message to notify systems administrators. We can use it to trigger auto scaling or lots of cool things we can get out of Cloudwatch. Now, when it comes to monitoring for our virtual machines, our EC2 instances, we've got two kinds of monitoring: basic monitoring and detail monitoring. Now, with basic monitoring, you get your data every 5 minutes and you don't pay extra for it. Now, I want you to think about this because I've seen this. If you get your data every 5 minutes and it's an aggregate or an average of your data every 5 minutes, what will that not show you? It will not show you the peaks and valleys. So, what if inside of that 5 minutes, at 2 minutes, your CPU was at 100% and the rest of the time it was 0? It will probably show 60% CPU load. Now, lots of times when you have applications that are not performing properly, there are these little performance spikes where either the network's 100% utilized or the CPU's 100% utilized, or something is going on. And if you get your data every 5 minutes, chances are you won't catch it. So you may need additional monitoring of your systems, and that's going to be called detailed monitoring. And that's where you get your data every 1 minute, but you pay extra for it. So if you want detailed monitoring, you can enable it. So let's talk about Cloudwatch events, Eventbridge, So that is basically part of the system, and the goal here is to deliver a real-time stream of events that can be sent to system administrators or let you know of anything going on in your environment. So the way it works is you're going to set up rules. If you know you have a memory-dependent application and you set the utilization when DRAM hits 75%, send a message, you can do that. If you've got a CPU application and you've got a CPU that doesn't, an application that doesn't perform well when the CPU is above 85%, you can set a notification as the CPU hits this. Maybe auto scale out and add capacity so your CPUs will be at lower load. And Cloudwatch events is kind of cool because it becomes aware of any kind of change as it occurs, and it can enable you to respond to these events and take corrective actions as necessary by maybe kicking off a Lambda function or making changes or even telling you. So we'll talk about Eventbridge, which is really Cloudwatch, is the new name for it. And really it's that real-time kind of thing. If this happens, you get to know about it. And this event can trigger something else. So with regards to Eventbridge, there's a couple concepts in case you see it on a test. I don't think you will at the associate level. You might at the professional level. But let's talk about the terminology. We have events. And that's going to be a real-time change in the system or data or the environment. We'll have basically sources of events or event sources. And that's going to be where the events are coming from. Is it coming from an S3 bucket, an application, a SaaS partner? And then we have what's called an event bus, which is going to be a virtual router that's going to receive the events and distribute those events to their destinations. We also have the concept of rules. And rules are basically going to be a set of instructions created with an event bus to match certain things. If this, then this. And then we're going to have a target. And the target is going to be where you send it. So do we send it to a Lambda function or a Kinesis stream or a message, that type of thing? So how is all this stuff working together? With this Cloudwatch event, this Eventbridge, new name, it's going to monitor something and it sees something, and then it's going to notify you. So why would an organization use this? We've probably talked about it a little bit, but let's talk about it a little more. If something happens, you want to be able to do something about it in that event-driven architecture, if you will. If this, then this. If you've got a lot of things going on, this thing can scale. And it's serverless. You don't have to think about how to manage it. It tends to integrate natively into AWS because it's an AWS service, which is great. You can integrate it. It's part of CloudWatch. It's part of AWS. You can use it with AWS X-Ray, which you can then use, which is a tool we'll probably talk about, making it easier to monitor and observe the performance of like your applications themselves. So we've covered the CloudWatch. We've covered the Eventbridge. So Cloudwatch is monitoring. CloudTrail is auditing. So CloudTrail is going to be an AWS service that's going to help with the auditing process. CloudTrail gives you an audit log that you can use for risk management and compliance purposes. So especially if you're in a highly regulated industry like healthcare, where I'm from, or banking, where I actually worked in for several years, you need transaction logs, and they need to be good. You need to see what changes have been made, when, how, and where, and why. So CloudTrail is great. So what happens is CloudTrail will track the events that are made by the user, an AWS role, or an AWS service. And CloudTrail is going to be enabled when you create the AWS account. And to set it up, basically you'll start a trail with the Cloudwatch console, or the CLI, or the API. And then CloudTrail will record these events, and these events will be visible to the user. And you can find them on the CloudTrail console. It'll let you see everything that's happened in the last 90 days, any major events. And if you want to store it longer, you can put it where? Object storage, the backup and archival, S3. So there's two options for the cloud trails you can create. You can create a trail that's local to a single region, so a one region only trail, and it will store your logs in a single bucket. And this is default. But is that going to work if you're multi-region? Now you're going to need to create a cloud trail, or a trail that applies to all regions. And this will give you much more comprehensive logging and auditing options, because it'll record all events that occur inside of your organization's infrastructure, not just in the region that you're in. So there's two major regions in the US, at least there used to be. Do you want it to only find out what's going on the East Coast of the US, or do you want the whole US if you're in both? So think about that. So here's the way you can kind of think about it. Something's happening on a virtual machine. Something's happened. An IAM user does something. It'll collect all those things, and it will store it in CloudTrail. Here's what I think. I think now is a good time for me to open it up for questions. I know we stayed a little late yesterday, but we are doing great time-wise, and I want to make sure that we give you some time for questions. So Tyrone, let's see if there's any questions. And while we're at it, please feel free to ask some. And while we wait to see, if you're having a good time with the video, please hit the like button. If you want to see new videos to help you in your technology career, cloud architect career, AI architect career, enterprise architect career, security architect career, or network architect career, please subscribe to the channel and hit the bell to be notified of new videos to help you. And hopefully my power holds on. If there's no questions, I'll let us end a few minutes early today, because we stayed late yesterday. So let me know. Are we going to go through some test questions? It's not something we planned on doing. We planned on giving you a lot of understanding of the tech and having you guys go through test questions at your own time, because I can't share somebody else's certification exams. And our focus as a company is really training architects and getting people hired. We just do these certification training camps for free for the following reasons. I've seen everything that was out there, and honestly, it terrified me. So I wanted to redo it and give away for free, because I wanted to make sure all of you had access to quality training and the ability to ask questions. Well, you need to know Python for entry-level AWS careers. So Actually, that's a very valuable question. And let me actually give you the reality. I don't think you should think about ever getting an entry-level job. Wait, what did I say? I don't think you should ever get an entry-level job. So I'm going to tell you why. It is going to be incredibly challenging to get an entry-level job, and it will be a lot easier for you to just move into a senior role. Here's the reason why. Most of entry-level jobs are click a few buttons here, type something basic into a keyboard. Here's the thing. I can write with Claude 3.5, a Python script, a Bash shell script, a Terraform script, that entry-level technician work. I can do that at entry level. And maybe you're talking about every level versus entry level, but I'm going to start entry level, and then I'll talk about every career as well. But you can get a more senior role. My first job, they had network engineers 1 through 4, and they had network admins at the company I joined, and I was made immediately a senior network engineer, network engineer 4. I can tell you that I've trained people all over the world whose first job is being a solutions architect. And here's the thing. That entry-level thing, I can hire 1 DevOps engineer to replace 15 cloud admins. So there's no reason for me to hire that entry-level person. At the same time, I used to hire entry-level for people to rack and stack servers and install the VMware hypervisor, for example. A lot of these systems are on the cloud. The cloud providers automatically do that. So there's much less of a need for me to hire entry-level people than there are. I hire people without experience all the time, and I've done it throughout my career. And I've got lots of people like Ivan Tambo or Coyote or George Kitko, whose first tech job was at the AWS as a solution architect after our training. We have people like Balwinder, who was a stay-at-home mom whose first job was a cloud solution architect at Microsoft. We have people like Wallace Agana, who was a sales rep, who immediately got hired as an enterprise architect, which is 1 step above a cloud architect at JP Morgan Chase. Or Daniel Bosa was another example of someone we got hired as a solution architect at JP Morgan Chase. I can give you examples in engineering, and I could give you examples all day. But the point is, it's going to be just as easy for you to train for a senior level career as it would be for you to train for a junior level career. But it's going to take you the same 6 to 12 months. It's just you study the things which talk about how do we leverage the technology for optimization of business or performance, or how do we learn how to configure the tech. It's going to take me the same time to trade you both. So you choose where you start. Most of my clients start with a job that pays 2 to 3 times the entry-level role, and that's how I started my career, and that's why I like people to do it. But that's neither here nor there. So the question of should you do an entry-level role? Now, the next question I'm going to interpret is, how about every role? Well, there's lots of roles you don't need to know Python for, and lots of roles you do. A cloud architect does not need to know Python. An AWS solutions architect does not need to know Python. An enterprise architect does not need to know Python, and they all have careers with cloud computing. A security architect does not need to know Python. A project manager or program manager does not need to know Python. A sales rep does not need to know Python. A VP of sales does not need to know Python. The CIO does not need to know Python. So understand that certain jobs require certain skills. By comparison, cloud admins need to know Python. Cloud engineers need to know Python. DevOps engineers need to know Python. So we need to more focus on what is the job we want and what are the specific skills for that job, as opposed to, do I need to learn Linux? Do I need to know Python? I know lots of great working architects that don't know how to use Linux, wouldn't know how to write a Python script, and are getting $300,000 to $500,000 plus architect jobs and maintaining these jobs. At the same time, I know lots of people that are trying to break into tech and they're looking for an entry-level role, and for most of them, they'll need to know Linux and Python. So what is the job you want? And then we have to determine what the skills are. The lawyer does not have to be a great runner, but a special operations warrior does. If you let me know the career you want, then I can help you figure out whether you need it or not. I'm happy to do so. Any others? All right, well, maybe we finished early. So if there are no other questions, and I'll wait a minute to see if one pops in. And, one of the things that I always want to think about is don't always assume all or nothing in your career. Every job is very different. Learning one job doesn't really teach you somebody else's. If somebody is a nurse and they want to be a physician, they still need to go to medical school. Will they be advantaged of what they learned? The answer is yes, but it is a new job. Working as an engineer and learning how to build and performance tune something does not necessarily teach you how to design something to optimize business performance, because it's a different job. Working as an airplane pilot does not make you a better lawyer. And that's one of the biggest challenges I see when people join tech, is they don't know where they want to go. Kind of keep that in the back of your mind. Do we offer AWS DevOps engineering? And we do not train engineers for. We are 100% focused on architecture jobs. Architecture jobs are near and dear to my heart. It's what I've done my entire life. And I love that architecture jobs are not affected by AI, because the whole point of the architecture job is designing systems to optimize the business performance. So what goes into that? Well, lots of conversations, lots of meetings, lots of sales, lots of presentations, lots of negotiations, meeting your clients and playing golf with them, for example. And I'm not joking, taking them out and entertaining them. That's a human to human to human job. So AI cannot replace an architect, because all of it, what we do is business. AI can replace some engineers, because AI can code. AI can write that Terraform script that a DevOps engineer would do. AI can write a YAML template that you would use in DevOps engineering for a Kubernetes cluster, for example. AI can write a Python script right now, and it's going to be a lot better in 2 to 3 years. AI can render Windows PowerShell script. So will there still be jobs for DevOps engineers? The answer is yes. But we may have less DevOps engineers doing the work of many more people because of AI and its impact on engineers. So that's why we've chosen not to train engineers and focus only on architects. I love engineers. They are the people that build everything I design, but my expertise is architecture. We have David Lithicum teaching with us, and his expertise is architecture. We've got PhD business school professors and MBAs teaching business and leadership, because that's their expertise and balance, and executive from tech companies. None of us are DevOps engineers, and we only teach things that we're good at, because we really want to make sure our clients are great. And we stopped doing cloud engineering because of my fear of training people for a job that won't be as strong in the future because of AI. Which AWS can someone with software venture skills develop in? So I love this question, but I want to change your thinking. You know what I used to do in my youth? You know what my degrees are in? Well, my last job prior to becoming an architect, I was practicing internal medicine. I was a paramedic. I became a nurse. I became a nurse practitioner, which is a nurse in the US. They can write prescriptions, do surgery, and have their own office. So I had my own internal medicine practice, but I love tech. What did I do? I got good tech training. I paid for it, and it was expensive, much more expensive than today's training, much more. I studied every day for 9 months. I actually became a CCIE in less than 9 months, and I was a network architect. Boom, it was overnight, less than a year. So the answer is anyone can do anything. So, Delroy Batt was a student of ours, and he was working on ambulances, and he got hired as a cloud security architect. Jeffrey West, you can see a video of him on our channel, and he was working in some kind of geospatial imaging, a non-tech role. Poof, he became a cloud architect, hired by Kalian. Richard Ferrari was working in banking. We trained him, and he got his first job at MUFG Bank as an architect when he was done. Lenny was our video editor, and now he's working as a solutions architect. So you can do any job you want. You want to become a physician, you can go to medical school. You want to become a lawyer, you can go to law school. You can be anything you want. All you have to do is believe in yourself, know you can do it, build a plan, get the right training from the right people that can get you to your goals, and you can do it. So you can do anything you want. You're not limited to software development. I mean, software development, if you had the right business acumen, could go into application architecture. I've trained software developers and made them cloud architects, but I've also trained mental health techs like Jennifer and gotten her hired, or school teachers, or social workers like Noah Parker, gotten them jobs as social workers. So, or Al Legister, he was selling consumer products, but Deloitte hired him as a senior solution architect after we trained him. I'm not trying to talk about our training here. I'm trying to say you can do anything you want. You can be anything. So I ask you, what would you like to do? And what are you willing to do to get there? That's the question I have for you, because you can be anything. You want to be a surgeon? You can do it. Want to be an architect? You want to do it. Want to be a DevOps engineer? You can do it. You can do anything. What do you choose to do? And I know you can do whatever you want, and I want you to be the best at it and love it. And one thing I learned in life is if you don't love what you do, it's no fun. So go love what you do. I love to teach. Maybe you can tell. I love it. Mark. Oh, Mark, it's always good to see you. I know you're in San Francisco. Thank you, Mike and team, for this training that is worth called. Thank you, Mark. I so appreciate that. Okay, well, thank you all for being here. If you enjoyed the content, please give it a like. We've got a whole lot of AWS services to talk about tomorrow. So lots more fun to go. Can't wait.